Hello guys, welcome back to Maths Zone African Motives. We are still on our revisions and this is our mathematics, the June examination that we are going to consider for our grade 12 that is from the Gauteng province. So that was our paper one. If we are to consider, this was our paper one, and you were supposed to answer this in within 3 hours as of the time that was given. So I'm not going to waste your time. Make sure that you go through the instructions and information. All right, read each and every part of the instruction and information that you're given, especially your answers. They must be given to two decimal places unless stated otherwise. So be very careful on the instructions, all right? And any other part that you're going to need, remember, you also have the information sheet that also you're going to use or to work with in case there is a formula that you have forgotten that you just want to cross-check. Remember that you've got what? The information sheet, which is limited. All right, it is limited to some formulas. That is the consideration there. Limited to some formulas, not all of them, but just some of the formulas. You have them here. All right, so like I said, let us quickly have our questions, and also you can download this question paper. All right, just check in the comment section. Just you're gonna check the comment section or the description of the video. You can download the question paper and the memo so that you go through also for the diagrams, you properly see the diagrams or even the questions the way that they are presented, just for revision purposes. All right, number one, question 1.1, solve for x. So meaning to say, this part of 1.1, all this part, it is what? To solve for x. All right, it is to solve for x. And there you are simply referring back to your grade 11 mathematics, everything that you did there. So that was the first part. 1.11, x squared plus 4x. All right, this is equal to 0. That is the first question that we are going to consider. So I understand most of you are used to your quadratic formula, which is okay. You can use that. But the best part, guys, when you're given this is just to factorize for 2 marks. All right. And also you have to check this statement correct to 2 decimal places. If you're not given this, it means you can easily factorize that given quadratic equation. All right, so here, considering that we've got 2 terms, I can simply factor out x as the highest common factor, the one that has got the smallest power or the lowest, which is what? 1. So that is it. X squared divided by x, that was going to give us x, 4x, and x, that was going to give us a 4, and equate this one to 0. So of these two terms, now I just gonna refer this as a term and this bracket also as a term. So that's the product of these two to be equal to 0. One of these must be equal to 0. So that is the condition that I'm going to simply apply or to use. So meaning to say I've got 2 solutions. One, the value of x that we already obtained here, x is equal to 0, and from this x plus 4, which is equal to 0, we can simply subtract 4 both sides of our equation. So x is going to be equal to 0 minus 4, which is what? Minus 4. So that's another value of x from the given equation. So I'm not saying quadratic formula is wrong for you to use the quadratic formula as you have this, from your information sheet, remember, you are given this part of your quadratic formula. As long you have your equation that is written in the form, as long your equation is written in the form ax squared plus bx plus c is equal to 0, you can use the quadratic formula. So in our case, we have this x squared just same as x squared plus 4x plus a 0. The value of c, the constant, is what? Is a 0. So that's equal to 0. So that you can properly see the coefficient of x squared, that's your a, your b, and your c. So from your quadratic formula where x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a, you can easily or simply substitute the values that you have stated here, a, b, and c. So x is equal to minus our b, that's 4. We're going to have plus or minus the square root of b squared, that is what? 4 squared. Minus 4 times our A is 1, and our C is what? That's a 0. So this is what you're going to have at the end. And that's 2 times A, where our A is what? Where our A is 1. So simplifying, I'm going to obtain the square root of, let us just use our calculator here, but that's a 16 because that one is going to give us a 0. So 4 squared minus 4 times 1 times 0 is going to give us what? 16. So that is the condition, over 2 times 1, which is 2. So from this, we can have the values of x. All right. Let's start with the positive from this square root. So that's negative 4 plus the square root of what? Of 16 over 2. All right. This was going to give us a 0, or x is equal to what? We consider the negative. All right. So let us consider our negative here. That was going to give us negative 4. So as we can see, we are obtaining same values even if we are to use our quadratic formula. So it's not limited. It's not limited, but it is just easier for you to work with what? The factorization. In this case, simply factorize, or you can apply your quadratic formula. It is in your hands. All right, so these are the typical questions actually that you are going to have in your revision. So all you just need is to work out as many questions as you can. All right, without wasting our time, let us consider 1.12, correct to 2 decimal places, still solve for x. There we have got a condition to 2 decimal places, meaning to say we are supposed to use our quadratic formula. And remember the format ax squared plus bx plus c is equal to 0 of the quadratic equation. So we must have one side equal to 0. So let us get rid of this 3x to the other side. Is going to be what? Negative 3x. All right, then we've got minus 1 over 2, and that's equal to 0. So this is the first stage that you are going to do to rearrange if you are to use what? The quadratic formula that I have listed before. All right, so using that quadratic formula, actually there's no need for you to clear these fractions. Yes, you can do that. Multiply by 2 by 2, the LCD of the denominators, both is the same as over 1 over 1. So you can clear those fractions. Then you use your quadratic formula, or you can simply use your quadratic formula because you can see your A, your B, and your C. So from our formula, remember x is equal to what? Minus b plus or minus the square root of b squared minus 4ac over 2a. All right, so let us quickly substitute our values. Negative our b, that's negative 3. So you're going to have plus or minus the square root of b squared minus 3 squared minus 4 times our a, which is 2, and our C is going to be -1/2. Can easily substitute as it is. Then 2 times A, that's 2 times 2. So you're going to simplify this. Minus and minus, that's a positive. Then we simplify this part that is under the square root, these numbers under the square root. So that was going to give us what at the end, right? So let us consider our calculator here. That's -3 squared, right? -3 squared minus 4 times 2 times -1/2. All right, -1/2 like this. That was going to give us a 13. So what we have under the square root is what? 13. The square root of 13 over 2 times 2, which is a 4. So from this, we can have the values of x. From what we have here, we can have what? The values of x. From the positive, we're just going to use the calculator. 3 plus the square root of what? Of 13/4. And this is going to give us 1,65. To 2 decimal places, shift, go to the setup, fix your calculator, press 2. So this is 1,65. Or x is equal to what? Let us consider when we have a negative. In this case, when we have a negative, that was going to give us, all right, let's consider -0,15. So this is what you're going to have to 2 decimal places using your quadratic formula. But remember, we also have completing of the square method as we had from our grade 11 mathematics. So you can easily, or you can simply apply that as well. It is in your hands, all right? But that is the condition that you had on 1.12. And like I said, you could have even simplified first. 2x squared minus 3x minus 1/2 is equal to 0. Some of us are not comfortable with the fractions. So this is same as over 1/1/1. So the LCD of these denominators is going to be what? 2. So I'm simply going to multiply each and every term by the LCD, each and every term. So what am I going to have? 2 by 2, that's going to be 4x squared. -3 by 2, that's -6x. All right, and this is going to cancel here. That's -1 is equal to 0. Then you can use your quadratic formula as before, where your A is 4, your B is -6, your C is what? -1. Substitute into your quadratic formula. You are still going to obtain the same values of x that we obtained before. So it is in your hands. All right, you could have simplified it in that manner. So now let us consider the next part, which is again to solve for x. And that's 1.13. All right, let us see what we have got here. 3x squared plus 5x. This is greater than or equal to 2. So take the 2 to the other side. That will be a negative, all right? So that's greater than or equal to 0. Remember, inequalities, they follow the same concept as your quadratic equations, all right? You must have one side equal to 0. So in our case, one of the sides must have a 0 like what we have here. So that's greater than or equal to 0. Then you need to find the critical values first. Remember the concept? You must have what? Critical values first. But in order for you to have the critical values, you can factorize, all right? So let us just consider that after factorization, I'm going to have what? 2 brackets here, greater than or equal to 0. So the factorization part, this one, it is in your hands, guys. Remember, your factorization, there are so many ways of what? Factorizing 3x squared plus 5x minus 2. Let us factorize. So using the cheat method that I've introduced to you guys and some other ways that you can use, but let us just apply the cheat method. 3 is going to multiply negative 2, so it's going to be x squared plus 5x minus 6. Then remember I said you must consider what? Factors of the constant, which will give us a positive 5. Since here the coefficient of x squared is what? Is 1. You're just going to have two brackets, x and x here. So what are these factors or products of what? Negative 6, which must add up to a positive 5, right? So if you have to consider factors of negative 6, there are so many factors, negative 6 and 1, 6 and negative 1, negative 3 and 2, 3 and negative 2. But of these factors, you're going to see that a positive 5 is obtained here when you add these two, 6 and what? Negative 1. So we're going to have a positive 6 and a negative 1. Remember the 3 that you multiplied here, you must return it back in place of x here and in place of x there. So that was going to be 3, 3 here. Then factorize where we have got a common factor. The highest common factor, in our case, the first bracket, we can factor out 3. That was going to be x plus what? X plus 2. If you divide, so you're left with 3x minus 1. The 3 that you factored out, remember I said, guys, this is useless. It's not part of your question. What you need are these two brackets. So meaning to say, we are going to have x plus 2, 3x minus 1. So the factorization part, how to obtain these two brackets, I'm saying it is in your hands. Use whatever way that you understand, but you're supposed to factorize first. After factorizing, that's where you can determine a critical value. Some, they use the quadratic formula. It is fine. You can do that. All right. So critical values will be the values of x that you're going to solve when this is equal to 0. You treat it as an equation when these two brackets are being equated to 0 as an equation. So x was going to be what? Negative 2. To the other side, that's a negative 2 that you're going to have. All right. Or our x was going to be negative 1 to the other side. That's 1. Then you divide by what? By 3. So it was going to be 1 over 3. Okay. So these are the critical values that we are referring to, which you can use now to find the exact solution to the inequality that you're given. Either you're going to use the number line or you're going to use graphical method, so many ways, the table method. It is in your hands now to determine the exact solution. So I'm just going to apply the graphical method. Using the graphical method, what I have here are the x values of a quadratic function. This is same as our f of x. So we're given a condition where f of x is greater than or equal to 0. And that f of x is quadratic where the coefficient here of x squared, remember our x squared here, the coefficient of x squared, which is a, determines the shape. So being a positive, like what we have at 3, it means our graph is going to be what? Concave up. All right? Because it's a positive. A is greater than 0, so it's going to be concave up. So that's a condition that you're going to consider with the solutions, x values minus 2 and another value at 1 over 3. Our graph is what? Is concave up, like this. So that is the condition of our f of x. So where are we going to have the values of x for which this function is greater than or equal to 0? That is when it is above what? The x-axis. Greater than or equal to 0 above the x-axis. And solutions above the x-axis will be taken here. Remember, guys, from our introduction, I discussed about this. This will be part of your solutions. Values that are less than what? That are less than minus 2, minus 3, minus 4, and so on. These values, they are less than minus 2. We have an equal to on our question, so you must have it on your solution. Or x is what? Values which are this side of 1 over 3, they are greater than 1 over 3. But remember, we have got an equal to. You must include that on your solution. So that was going to be our solution. These are the possible values of x. All right. So like I said, you can even use the number line to find the final solutions. It is still in your hands. You're going to obtain the same answers at the end. All right. So let us see what we have on 1.14. Again, we are solving for x. Remember, all this, it is to solve for x. So let us see what we have. This part of our exponents. Remember, from our grade 11, we had these exponential equations. So that's 2 to the exponent of 2x plus 2 to the exponent of x minus 6. And that's equal to what? Equal to 0. From this, we can actually solve this one as it is, because 2 to the exponent of 2x, this one can be written in so many ways. It can be written as 2 to the exponent of 2 to the exponent of x. It can be written as 2 to the exponent of x raised to the exponent of 2, like this. It is one and the same. So as we need a condition, this one, where we have 2 to the exponent of x, this. So this is the condition that we're going to need. 2 to the exponent of x what? Squared. So if you understand that this 2 to the exponent of 2x can be written as 2 to the exponent of x to the exponent of 2 like this, it means you can solve this. It's actually a disguised quadratic equation. The highest power is 2. You can solve as it is direct, or you can let a constant k be equal to 2 to the exponent of x, so that you can properly see the quadratic equation that you are working with. Not to say it's not possible for you to solve it. Okay. So if k represents 2 to the exponent of x, it means this is what? K squared, right? The whole part of 2 to the exponent of x is represented by what? By k, but there is a square. So that's k squared plus 2 to the exponent of x, that's our k, minus 6 is equal to 0. Are you seeing that? We are back to a normal quadratic equation that you're used to, where you can use a quadratic formula, or you can simply use your factorization. Since the coefficient of k squared here is 1, therefore I'm going to have k and k here, just like before, guys. Factors of what? Negative 6, which will add up to positive what? Positive 1. The coefficient of k here is positive 1. So what are these? Products of negative 6 or factors. There are so many. Remember, I listed these ones before: negative 6, 1, 6 and negative 1, negative 3 and 2, 3 and negative 2. But of these factors, which part, when we add, we are going to obtain a positive 1. This happens between 3 and what? Minus 2. 3 plus minus 2, that's a positive 1. So we're going to have plus 3 minus 2 equal to what? Equal to 0. So let us solve, as we have got the product of these two brackets. One of these must be equal to 0. So that's it. So k is equal to what? Positive 3 to the other side is going to be a negative 3, or k is equal to what? Negative 2 to the other side is going to be what? A positive. So k is equal to minus 3 or 2 from what we are given. This represents k, not x. This question, we do not have k there. It is something that we introduced late. We introduced it to be part of our question. So at the end, you must solve for what? For x. Do not forget that you are being asked to solve for x, not k. So to solve for x, our k, back to what we are given. 2 to the exponent of x is equal to minus 3, or 2 to the exponent of x is equal to what? Is equal to 2. So you will see that on the first part, it is impossible that minus 3 is going to be raised or to a certain power, then you have something like this, or 2 to the exponent of x is going to give us a negative 3. That's actually impossible. All right, so there's no solution on the first part. Then the second one, if you are to consider that we've got same bases here, so it means we have the value of x, because 2 is same as what? 2 to the exponent of 1. So since the bases are the same, it follows that we are simply going to equate our exponents. So therefore, x is equal to what? X is equal to 1 from what we are given. X is going to be equal to what? To 1. So many ways. All right, so just also consider the memo so that you can see other ways. Maybe there's another way that you do understand on how to answer that. You try that way. So many ways. This is maths, guys. You mustn't be limited to only a single way. There's so many methods, ways of what solving. All right, let us consider another part of our question, which is 1.15, still solving for what? For x. There was a little bit tricky question, which could have also been done in so many ways, but we could have just considered something that is happening here. I want you to see something. Are you seeing that we have got this x squared minus 2x, x squared minus 2x, this. If you had to expand these brackets, guys, it was going to be complicated. Like, let's say you want to remove the fractions, then you say, all right, this is same as over 1, so I'm going to multiply by x minus 2 here, x minus 2, x squared minus 2x. You do the same thing here, you do the same thing here. It was going to be complicated. Why? Because you're going to have this x squared and x squared, you're going to have something like to the exponent of 4. And remember, you have to multiply to everything, this part to this one. So it's going to be a lot. But if we consider that this here is the same, this is the same, let us introduce a constant for that so that it can at least reduce our calculation at the end. Yes, we could have worked it like that, but we can try to reduce it. So if we are to reduce it, we can introduce our constant k be equal to x squared minus 2x. So if k represents x squared minus 2x, it means I'm just going to place this with what? With k there. So that's k plus what? Plus 3. Take note, there is a plus 3 there. So k plus 3 is equal to, I do the same here. So also that's a plus, no, equal to, that's a plus here. So that's plus 2 over what? X squared minus 2x, that is the whole part representing what? Representing k. And that's equal to 0. Are you seeing that we have reduced our fraction so that even if you are to clear those fractions the way that we wanted to do here, to say this is over 1, then you multiply by the LCD, it will be easier because you're multiplying by what? By k to k plus 3. So let us clear our fraction. This is same as over 1. This is same as over 1. So you can clear these fractions by multiplying each and every term by the LCD of the denominators, 1, k, and 1. So that's our LCD is what? Is k. So multiply each and every term. You multiply by k here, you multiply by k here, you multiply by k here. So k is multiplying what? K plus 3. All right, so that's k into k plus 3. All right, plus the k and the k was going to cancel. You remain with what? A 2. And that's equal to 0. Any number times 0, guys, is going to give us a 0. You have formed a quadratic equation here that you must solve. Why am I saying a quadratic? Remember, k times k is what? K squared. All right, k times 3, that's going to give us 3k plus 2 is equal to 0. So I can simply solve for k. It's a quadratic, so I'm going to have two solutions at the end. All right, so let us have our two brackets and equate to 0. So this is k, this is k. What are the factors of what? Of 2. Factors or products of 2 which will add up to positive 3. Just focus on those two. So factors of 2, that's 2. We have got 2 and 1, minus 2 and minus 1. These are the factors of 2. But when we add, we must obtain a positive 3. So it happens on what? 2 and 1. 2 plus 1, that's a 3. So that's 2 here plus 1. So you can find the values of k. 2 to the other side, that's a minus 2. Or k is equal to 1 to the other side, that's negative 1. From these values, k, we are not given a condition that this is not supposed to be what? It's not supposed to be. We are not given a condition that k is not supposed to be equal to this value. But we can conclude now by solving from what we had introduced. Remember, we said let k be this. Let k be x squared minus 2x. So where I'm having this, I'm supposed to solve for x, not for k, for x. From that given condition, if our k is equal to x squared minus 2x, guys, what is our k? Our k is minus 2. That's the first one. So x squared minus 2x must be equal to negative 2, the value of k. Or x squared minus 2x must be equal to what? Negative 1, the value of k. Then we can solve for x. So as you can see there, they are both quadratic. You formed a quadratic equation again. So let us try to solve this one. That's x squared minus 2x plus 2 is equal to 0. So there we're going to see that 1, it cannot be factorized yet. Factors of 2, which adds up to negative 2, that cannot be factorized. So you try quadratic formula, then you're going to see that even quadratic formula you cannot solve. It was going to be something like this. X is equal to minus b minus minus 2 minus b, that's something like this. Sorry for that. Minus minus 2 plus or minus the square root of b squared minus 2 squared minus 4 times a times c, which is 2. So you're going to see that under the square root, you're going to obtain a negative. Minus 2 squared, that's a 4. Minus 4 times 2, that's 8. And you're going to have the square root of minus 4, which cannot be simplified. You cannot simplify that. So meaning to say, the first part, when our k is when this part of k is minus 2, we're not going to have a solution from there. All right. We could have just seen from the factors that there are no factors because there's no even have decimals there. All right. Anyways, so the first one is out. Let us consider the second one. This is going to give us x squared. All right. That's x squared minus 2x. Then minus 1 to the other side is going to be a positive 1. So that's equal to 0. From the side, we can see that this is a perfect square. All right, this is a perfect square, but if you can't see that, then simply factorize. You see that one later on, but that's a perfect square. Factors of what? Of 1, which will add up to negative 2. Negative 2, that's negative 1 and negative 1. So meaning to say, you are going to have x minus 1, x minus 1 equal to 0. So are you seeing this as simply as x minus 1 what? X minus 1 squared. That's a perfect square. Anyways, from this bracket to the other side, x is equal to 1. From the other bracket, still they are the same, so x will be equal to 1. So that is the value of x that we are going to consider from this part. Our x is equal to what? Our x is equal to 1. The first one, where k was minus 2, it is what? Impossible for us to solve that one. The second one, we can solve. So from there, you've got the value of x. Remember, answer the question, guys. So we had the value of x. It's not about solving for k. Do not solve up to k here, then you say you are done. No, answer the question. So these are the stages that you're going to have All right, from what you are given, just introduce a k, any constant, solve for that k as usual. Then after, substitute back to that path where you introduced your k. You solve the given equations just like that. All right, let us consider another part, which is of our simultaneous equations on 1.2. You were asked to solve for x and y simultaneously for 6 marks. All right, so that is our grade 11 again, this part. All this question number 1, guys. No, I left 1.16. I left something here, 1.16. Let us consider that. All right, so it is all right, let us consider 1.16 first. Then we move on to our simultaneous equations, this and that. So you see, guys, it's just basic. It's just basic. Number one, you must totalize these 30 marks. You must just obtain all this. This is your grade 11 as it is. So nothing new as it was before. All right, look at this one. Solving for x, this is equal to -1. Okay, we need to isolate the square root. We need to make this the subject of the formula. So what I can simply do is to get rid of the minus x to the other side. So it's going to be a positive. So it was simply going to be the square root of what? X plus 5, which is equal to positive x, all right, minus 1. As I have this, I can simply get rid of the square root by what? Squaring both sides. So you have to square both sides of your equation. So that was going to give us x plus 5. The square root and square cancels. So x plus 5 is equal to, remember your binomial expansion is going to be x squared minus 1 times 2. That's minus 2x plus what? Plus 1. All right, we can use our binomial expansion, or simply expand 2 brackets x minus 1 into x minus 1. That's x and x squared, and this minus x, and this minus x, minus 1 and minus 1. That's a positive 1. So it was going to be x squared minus 1 minus 1. That's minus 2x plus 1. So this is what you're going to have at the end. Remember, that's a quadratic equation. The highest power there is 2. So take these other terms to the other side so that you remain with a 0. So that's 0 is equal to x squared. X to minus 2x will be a negative. Minus 2x minus x, which is what? Negative 3x. All right, 5 to the other side is going to be a negative. So that's 1 minus 5, which is going to give us a negative what? A negative 4. So this is what you're going to have. And with this, you can easily solve. That's back to our factorization, guys, as we are dealing with our quadratic equation. We are back to our factorization. The coefficient of x squared, remember, that's a 1. So what I can simply do here is to have my 2 brackets. All right, I'm just going to have my 2 brackets. Considering factors of what? These are factors of -4, which will add up to -3. Or you can just use your quadratic formula. It is still one and the same. But here we can simply factorize. All right, so what are these factors? -4, there is -4 and 1, 4 and -1, -2 and 2. But we need a condition. When we add, we are going to obtain what? A -3. And -3 is obtained here. -4 plus 1, that's a -3. So meaning to say we've got -4 and a +1. So thus we can have the value of x. -4 to the other side is going to be a +4, or x is equal to what? 1 to the other side was going to give us a -1. Remember, this is being taken from a set. A set. These are sets from our sets. So you must test for the value of x that you have obtained, substitute back into the original equation, and see if you are going to obtain a -1 for the value of x. So you are, or you must test these values that you have obtained here. All right. So to test, let us consider when x is what? When x is 4. Just substitute into this as it is the left-hand side and see if you're going to obtain a -1 when x is what? When x is 4. On your calculator as it is, all right? So that's the square root of what? Sorry, the square root of, remember our x is what? 4. When x is 4, you put 4 here, you put 4 there. So that was going to be 4 minus 4 plus 5, I mean 4 plus 5, then minus what? Minus 4. All right, so that is what you're gonna have here, which is -1. So -1 is exactly equal to this -1. So for the value of x, it means it is going to satisfy our equation when x is what? 4. What about when x is -1? So you simply do the same. In place of x, put -1. So here I'm going to put -1. Here I'm going to put -1 like this. I'm going to put -1. So as we can see, we're obtaining a 3. And 3 is not equal to what? Is not equal to -1. Remember, you're comparing to -1. 3 is not equal to -1. So it means our x cannot be equal to this -1. It is giving us another value which is not. So x cannot be equal to what? -1. So therefore, our x was going to be what? Was going to be a 4. Just like that. So that is how we could have solved our sets. These are sets, our equations that have got these square roots from our grade 11, like I said. All right. Then 1.2, the simultaneous equation. All right. Considering what you are given here for 6 marks, one of these equations, as we can see, it is a linear and the other one is a quadratic. So we have got a linear equation. So just name that one your equation 1 and this one your equation 2. So what I'm going to simply do is that from my equation 1, I can simply make x the subject of the formula. So x is going to be equal to 5 minus 2y. 5 minus 2y. So this will be my equation 3. I made x the subject from equation 1. And now I have got equation 3. So what I'm going to simply do is to substitute my equation 3 into what? Into equation 2. All right? Into equation 2. Remember your substitution method. So in place of x, you are supposed to put that 5 minus 2y. So this is 2y squared. All right? Minus xy. If I write minus xy like this, it is the same as minus yx. You can start with y there. So you can start with y, then x. Our x is what? Our x is 5 minus 2y, remember? So that's 5 minus 2y representing our x. So we have simplified this. Minus 4x squared. So that's minus 4x. Our x is what? 5 minus 2y. But being squared, and that's equal to 8. You're done. So as we can see from this, you can simply solve for y. It is easier, guys. Just expand brackets, collect like terms. All right. Minus y times 5, that's minus 5y. Minus y times -2, that's going to be positive 2y squared. All right. Negative, negative, that's a positive. All right. There we've got a bracket that has to be squared, raised to the exponent of 2. So you must consider that, right? So the minus 4 is simply going to multiply the resultant of what you're going to have here. So it's -4 into what you're going to obtain when you've expanded this bracket, which was actually from that expansion, it was going to give us 25 minus 10 times 2, which is 20y plus, this is going to be 20. 20y plus what? 4y squared. All right, like this. Or you can easily just expand your brackets, all right, the way that you're used to. There are two brackets. Here, just apply the concept of a minus b squared, which is what? A squared minus 2ab plus b squared. Or you can simply expand your brackets. 5 minus 2y, another bracket, 5 minus 2y. So 5 times 5, that's 25. 5 and negative 2, that's negative 10y. Minus 2y and 5, negative 10y. Negative 2 and negative 2, that's positive 4y squared. So collecting the like terms, minus 10 minus 10, that's minus 20y plus 4y squared. So as you can see, that's the same thing that you're going to have there. And that is equal to what? And that is equal to 8. So expansion of brackets is actually in your hands. Expand the way that you understand. You can simply use those identities under your binomial. All right, this is what you have got here. And what I can simply do is to expand this bracket here by negative 4. Negative 4 is to multiply each and every term. All right, but here I've got like terms. As I am to expand these brackets, here I've got like terms 2y squared and this 2y squared. So simply add those two. So 2 plus 2, that's what? That is going to give us a 4. So 4y squared minus 5y. All right, let us expand the bracket by what? Negative 4. Negative 4 times 25, that's going to be negative 100. Negative 4 and negative 20, that's going to be positive 80y. Negative 4 and positive 4, that's negative 16. So that's negative 16y squared. And I can even take this 8 to the other side. That will be a negative 8. And that's equal to 0. All right, so that I just simplify everything at once. On the left-hand side, I've got like terms, so I have to consider those like terms together. The part of y squared, I have got this 4y squared, and I've got minus 16y squared. So if I'm to consider like terms, that's 4 minus 16, 4 minus 16, which is going to give us negative 12. So negative 12y squared. All right, negative 5 plus 80. That is the part of y there. Those are like terms. We have got y here and y here. So negative 5 plus 80 was going to give us positive what? 75. Use your calculator there. That was going to give us positive 75y. And minus 100 minus 8, that's minus 108, equal to 0. All right, use the calculator. And as you can see, you want to solve for y there. So some of us, yes, we can just use the quadratic formula direct as it is like this. Use your quadratic formula. But if you have to use those factorization, so try to reduce now. All right, you can find the highest common factor between these numbers, minus 12, 75, and 108, and that is going to be 3. But avoid the negative, so just use it as what? Negative 3. So if I want to divide by the highest common factor of these 3, which is minus 3, so that was going to give us negative, that's positive. Positive, negative, that's a negative. All right, so that's negative 25y. Negative, negative, that's a positive 108 divided by 3. That's 36, and that's equal to 0. So this is what I am having, and I can solve from the quadratic formula. It is okay, or I can use factorization. So guys, I'm not focusing on the quadratic formula because most of you are used to that, all right? So simply use it, guys, A, B, C, if you're used to quadratic formula. But I'm doing the factorization so that also we get to understand again that factorization can also be easier as our quadratic formula is. All right, so here I'm simply gonna factorize, but you can use what? Quadratic formula. So factorizing, I know that I'm going to obtain 2 brackets since the highest power is what? Is 2. All right, so here I've got 4y squared minus 25y plus 36. Using the cheat method, I'm supposed to get rid of this 4, multiply to the constant. So that was going to be y squared minus 25y plus what? 36 times 4. That was going to give us 144. So what I need here are the factors of what? 144, which will add up to negative 25. Factors of 144, two numbers that you multiply, you obtain 144. That's between 9 and 16. If you multiply this, all right, 9 times 16, it's going to be 144. But to obtain a negative 25, it means these numbers must be what? Negative, negative. Remember, negative times negative is what? A positive. But if I add this now, minus 9 plus minus 16, if I add minus 9 plus minus 16, like this, it's going to give us what? A negative 25. So these are the ones that I need. Negative 9, negative 16. Then bring back the 4 in place of y here, in place of y there. So that's a 4 here, that's a 4 there. All right, so the first bracket, nothing is common. But in the second bracket, 4 is common. So if I factor out this 4, then the second bracket is going to be y minus 4. 16 divided by 4, so it's going to be 4. And this first bracket, nothing is common, so it remains as it is 4y minus what? 4y minus 9. This is useless. So what is inside the bracket is what we need. So that's y minus 4. 4y minus 9. Any order, the order here does not matter at all. You can start with any one of these. All right, so this will give us the value of y from there. Minus 4 to the other side will be a positive. Or y is equal to what? Negative 9 is going to be a positive 9. Then you divide by what? You divide by 4. So that's 9 over 4. Those are the values of y that you are still going to obtain if you are using your quadratic formula. All right, it's not a problem at all. So what we need here is to find the values of x from which equation now? All right, remember equation 3. Remember your equation 3 where we made y the subject, x the subject of the formula here in equation 3. So we can actually take advantage of that because x is already the subject. X is equal to 5 minus 2y. So I can substitute back into equation 3 where x is equal to what? 5 minus 2y. So if x is equal to 5 minus 2y, therefore find the y values for this. Find the x values. X is equal to 5 minus 2 times the value of y here is what? Is a 4. So that is the idea. All right. So this is going to give us the value of x. Using your calculator, straightforward, that's 5 minus 2 into 4. All right. And this was going to give us a negative 3. All right. So x is negative 3 or x is equal to what? When y is 9 over 4, so that's 5 minus 2 times our y there, which is what? 9 over 4. So that was going to give us another value of x. All right, so simply substitute 9 over 4 in this bracket. That's 9 over what? Over 4. And that was going to give us 1 over 2. So that's the value of x that you are going to have when our y is what? 9 over 4. Our x is going to be 1 over 2. From this one, our x was going to be what? Negative 3. So this is the condition, just like that. So you see, guys, simultaneous equations, this is just a revision, a recap. The question number 1, actually, question number 1, it is a recap of your grade 11. All right, so that is how you're supposed to solve this one, simply using the substitution method. All right, 1.3, to mark the last question of number 1 to obtain 30 marks. Guys, you must obtain these 30 marks. You must totalize for this one, guys. All right, this is your grade 11, all of this. All right, for which values of k will the roots, all right, of this equation be real and equal. Once there is that part that the roots, they are equal, they are real and equal. So it means simply our delta must be equal to what? Our discriminant must be equal to 0. Remember, for real, our delta must just be greater than 0. And when we have got equal roots, your delta must be what? Must be equal to 0. So that's the condition that you're going to have. If our delta is equal to 0, from this equation, remember we must have it in the form ax squared plus bx plus c is equal to 0. So that's from our quadratic equation. Then we can have our discriminant. So let's take the the 4x to the other side is 4kx. So it's going to be a negative. So that will be 6x squared minus 4kx. We need the format x squared. You move on to x to the constant. All right. So that's where we have got our x. Then the constant is already on the left-hand side and it's what? A positive there. So this is it. Find your delta. Find your discriminant. Remember, our delta is what? B squared minus 4ac. So our A, our B, the coefficient of x, this will be our B. And C is what? The constant. So that's it. That's our delta B minus 4k, the coefficient of x. But it's what? B squared. Minus 4 times A, our A is 6, and our C is also a 6. So this is what you're going to have at the end. Minus 4 squared, minus 4 being squared, give us positive 16k squared. All right, minus 4 by 6 by 6. That was going to give us 144. Negative 4 by 6 by 6. That's negative 100 and what? 44. Remember the condition of your delta, b squared minus 4ac. You have it now. But on a condition that these roots, they are real and equal. They are supposed to be equal, guys. So that delta must be equal to 0. If delta is equal to 0, then solve for what? Then solve for k. So 16k squared minus 144 is equal to 0. Can be solved in different ways. You can use the quadratic formula. You can use your factorization in so many ways. All right, there's a difference of 2 squares. 16 is a perfect square because the square root of 16 is what? Is 4. 144 is a perfect square because its square root is going to give us a 12. So meaning to say, we're going to need a difference of 2 squares, a squared minus b squared. So that's going to give us 2 brackets equal to 0. Square root of 16, that's 4k here. Square root of 144, remember that's a 12, so it's going to be minus 12. All right. You could have factored out the ST common factor, but which is not important when it is like this. 4k plus 12 is equal to 0. So let us solve. Each bracket must be equal to 0. So 4k will be equal to 12, or 4k will be equal to minus 12. So divide by 4 by 4. Our k was going to be equal to what? 3. All right. Or our k here, if we divide by 4 and 4, it was going to give us a negative what? A negative 3. So this is what you're going to have. That is why here they said what? For which values of k, values. That's why we're obtaining 2 values there. It's not a single value. They are values. All right. So k can be equal to positive 3, or k can be equal to a negative 3. That is the condition that you're going to have or to use. All right. So you see, guys, easy. Just a matter of working out more questions. It's all about revision, but it was a little bit easier, as we can see. All right, question number 2. We are on question number 2, considering our number patterns, this and that. We are given here thus 3 terms of an arithmetic pattern. All right, that's what we have. And there are just 3 of them. Okay, so what can we do with these 3 terms? Write down The next two terms of the pattern, already you're told it's an arithmetic pattern where you do understand there you're going to work with what? A constant difference. So if it is a constant difference, let us know that constant difference. -5, 2, and 9, these are the terms T1, T2, T3. And that constant difference D is simply T2 minus T1 and so on. All right, from the Tn minus 1 concept. So meaning to say, in our case, T2 minus T1, I'm just going to subtract. That's 2 minus, what am I subtracting? -5. This one minus this one. So it's going to be a positive at the end. 2 plus 5, that's a 7. So the difference between these two is 7. 9 minus 2, that's also a 7. And so as you can see, guys, it's truly a in arithmetic. What's the purpose of finding this constant difference? It is the one that has been added from one term to another. If we add a 7 here, we get a 2. If we add a 7 here, we get a 9. So if we add a 7 here, what are we going to get? The next term, 9 plus 7, which is going to give us a 16. The same thing, if we add a 7 here, we're going to get a next term, which is 16 plus 7, that is 23. So those are the next two terms that you're going to have, 16 and what? And 23. All right. Then 2.12 show that the sum of the first any terms of the pattern is given by this. The sum. This is the sum of terms of what? An arithmetic. Sum of terms, if you've forgotten, guys, the formula sheet is there as an assistance. All right. The sum of terms of an arithmetic can be given from this formula here. Sn is equal to this, or you can use Sn, which is the one when you are referring when you've got A plus L, but you must have the last term, A plus L, the last term. But in our case, we are not given the last term. So the best formula for the sum of terms was going to be this one. All right. So considering our formula for the sum of terms of an arithmetic, we can prove that, all right, because we do understand that our Sn is given by n over 2 into 2a plus n minus 1 times what times d, where we have got a as the first term, so our a is already -5. It's already given, that's our T1. All right, then our constant difference is the one that we have already calculated here, which is what? A 7. So substitute into the formula and simplify n over 2. That's into 2 times a. Our a is what? -5. All right, plus n minus 1 times our d, our constant difference of what? Is 7. So this is what you're going to need. Then from here, you have to simplify, collecting like terms, this and that, up to the last stage, this one that you're given. So that's our Sn here is going to be n over 2 into what? 2 times -5. If you multiply that, that is going to give us what? That is going to give us a -10. You're multiplying this, all right? Then plus 7 times n. This is going to give us 7n. 7 times -1, that's a -7. So expand that bracket. Then what you can simply do is to collect the like terms in within this bracket. I have got 7n. All right, I've got 7n minus 10 minus 7. That's what? -17. So as you can see, guys, this is exactly what I'm given there. So it is the same as how it is presented. N over 2, it is same as half of n. So it is the same thing that we are being given there. We have already simplified up to the last stage. So that is what you're being asked to show that. All right. So that's it for 3 marks. You already have the answer there. So they can ask such typical questions, all right? Just a matter of answering, substituting, simplifying, then write the exact way that you're given on the answer. Your solution or whatever presentation that you're going to have must be exactly as it is given on your answer. All right, 2.2, you're now given This is an what? Quadratic pattern this time. The first four terms of a quadratic, remember quadratic, that's where we have got the second constant what? The second constant difference. That's the second constant difference. That the second difference is the same throughout. That is the property of a quadratic. It is, you must know the property, guys. If you're given an arithmetic constant difference, the first differences that you have must be the same throughout. It's an arithmetic. That is the property. So what about a quadratic? Is property the second constant, all right? So here they are asking us on 2.21 to determine the value of x. I can simply use that condition because I can form an equation from there, all right? 2.21. So I can simply form an equation from these terms, all right? Let us see what you're going to have here. I can simply form an equation from that statement that the second uh, difference is supposed to be what? The same, constant. So let us find the differences from the terms. And I have the first differences here. So this is our T1, our T2, our T3, and that's our T4. So we need the difference T2 minus T1. All right, T2 minus T1. It simply means we're going to subtract 3x like this, 3x minus 5 minus x. So this is 3 minus 1, which is 2x minus 5, collecting the like terms. So it was going to give us 2x minus 5, right? The same here, T3 minus what? T2. T3 minus T2. You do the same thing, but take note, our T3, that's 4x minus 3, subtracting T2, that's an expression, open a bracket for that 3x minus 5 so that you can properly subtract 4x minus 3 minus times 3x minus 3x minus times negative 5, that's going to be a positive 5. So 4 minus 3, that's 1x, minus 3 plus 5, that's a positive 2. So it was going to be x plus 2. All right, then the same T4 minus T3. So you're going to have to do the same. There is a brackets. I mean, you're dealing with an expression, so just open brackets. T4, 5x plus 1 is subtracting 4x minus what? Is subtracting 4x minus 3. So that's going to be 5x plus 1 minus 4x minus, that's plus 3. All right. 5 minus 4, that's 1. So it's going to be positive x. 1 plus 4, 1 plus 3, that's a 4. Okay, so this is what you're going to have from that part. So we have got our first difference, then we need the second one. So let's find the second one. From the second one, we can form an equation from there because you know that the second difference is what? Is constant. So second difference is here, all right? So this one minus this one, just like before, x plus 2 is going to subtract 2x minus 5. Right, let's see what you're going to have. X plus 2 minus times 2x minus times minus, that's a positive 5. So x minus 2x, that's minus 1x, which is minus x. 2 plus 5, that's a 7. So you're going to have minus x plus what? A 7. All right, this one minus this one. So that's x plus 4 subtracting what? Subtracting x plus 2. So that's x plus 4 minus x minus 2. X minus x cancels. 4 minus 2, that's a 2. So here I'm going to have a numerical value, which is 2. But remember, that's our second what? Our second difference that we're having now. And we are saying this is a quadratic where this second difference is the same, is constant. So we can see that if there's a 2 here, it means here, the next one was going to be a 2, even this minus x plus 7. It is a 2 numerically. Numerically, it is what? It is a 2. From this concept, these two, they are equal. They represent the same thing. So from there, you can solve an equation. Say minus x plus 7 is equal to 2. Since we know that from our quadratic, these second difference will be will be the same throughout. So I have formed an equation where I can solve for what? Where I can solve for x from this equation. So minus x is equal to, all right, taking the 7 to the other side, that's going to be a negative. So that's 2 minus 7. So minus x is equal to 2 minus 7, that's negative 5. Divide by negative 1 by negative 1. So that's obtaining the value of x. Negative, negative cancels. So that is going to be what? A positive 5 at the end. Just like that. So we have the value of x. So you simply work with what? The type of what pattern, the number pattern that you're given is a quadratic. So you know the properties there are on the second differences, which is what? Which is constant. Then we are being told that if the pattern continues indefinitely, prove that all the terms of the pattern are what? Positive, all the terms. So you must find Tn, then we can prove from that Tn if the terms are positive or not. But here we are supposed to prove that they are positive. So definitely, guys, you must find Tn. So before we talk about this question, let us find our Tn. How can we find Tn? Remember, this is a quadratic, and what I need is going to be the second difference, this term, and our T1. So those are the ones that I'm simply going to need from the value of x that we have here, which is what? Which is 5. Let us substitute that value of x and see what you're going to have. If our x is 5, here already it's a 2. We know that these two, they are equal, remember. So here we know that this is going to give us a 2 numerically. This will be a 2. All right. So that's the idea here. All right. Then that's it for the first, for the second differences. Then here our x is 5, remember? So 2 times 5 minus 5, that was going to give us a 5 here. This whole part was going to give us a 5. If you substitute the value of x, this was going to give us a 5. Our x is 5, so if you substitute that x here, it means that was going to be a 5 again. So this T1 was going to be a 5. All right, so let us find our Tn. Of a quadratic, we do understand that our Tn is equal to an squared plus bn plus c, which there are so many ways of finding this. All right. From the second differences, we do understand that 2a is equal to the second difference, which is 2. So divide by 2 by 2, a is equal to what? 1. Then this 5 is simply equivalent to 3a plus what? 3a plus b. That's our first term for the what? First differences that we are having. It will be equal to 3a plus b. Remember, guys, I talked about different ways of solving for this. So you can simply use any one. All right. When a is 1, substitute that's a 3. So b will be equal to 5 minus 3, which is what? Which is 2. Then the last one is going to be taken from the first term, which is equivalent a plus b plus what? Plus c. So a plus b plus c is equal to 5. You must be able, guys, to write this. It must be in your hands. Mathematics must be in your fingertips, guys. All right, it must be in your fingertips. That's the whole part of maths. So this we said is equal to 5. Our a, b, we have it 1 plus 2 plus c is equal to 5. So that's 3 plus c equal to 5. So our c is equal to 2. All right, 5 minus 3 is going to give us a 2. With this value of a, b, and c, we can simply substitute into our given equation, our Tn, our general formula. All right, with these values, like I said here, our Tn is supposed to be taken from what? An squared, our a, that's 1, so that's n squared, plus our b, which is 2, so that's 2n, plus our c, which is 2, like this. So this is our Tn. But how can we prove that for these, for any value that we're going to have of any, this will be positive? All right. if it was to be factorized, I was going to factorize, because the question is not about finding Tn, guys. The question here is, if the pattern continues indefinitely, prove that all the terms of the pattern are what? Positive. So we must have a positive expression that we can be sure about, that this is a positive expression. Yes, by looking into this, we can see that if for any value of n, this is going to be positive here, but we must prove that. All right? If this can be factorized, n squared plus 2n plus 2, but it is limited because of this 2. We cannot factorize because we do not have factors of 2 which will add up to 2. 2 and 1 minus 2 and minus 1. We cannot add these and obtain a 2 again. So let's try to separate that 2, because it is the one that is limiting. 2 is same as 1 plus 1. So meaning to say, I can rewrite this, our Tn, as n squared plus 2n plus 1 plus 1. I haven't changed anything. 1 plus 1 is what? Is 2. But what I need is to have a quadratic expression that can be factorized. And in our case, if we are to consider this part, right, let me indicate it here. This n squared plus 2n plus 1, it can be factorized this time. We can factorize this. Remember, we expanded 2 and said it is same as what? 1 plus 1. But this, can it be factorized? Yes, it can be factorized. So I want you to see how. All right, let us consider now this part, n squared plus 2n plus 1. So if you consider factors of 1, which will give us a 2, they're there, 1 and 1. Actually, like we did something like this before, which gave us that squared. So 1 and 1, they give us a 2. So meaning to say, we can actually factorize that into n plus 1, n plus 1. Factors of 1, which gives us a 2. So that's n plus 1, n plus 1. We factorized this. Remember, we factorized this. So what is going to happen with this plus 1? It remains as it is. So you must have a plus 1 there, this one, that was already part of your percent. So that's our Tn. N plus 1 times n plus 1. 2 times 2 is what? 2 squared. So what about n plus 1 into n plus 1? It simply means n plus 1 squared. So this is n plus 1 squared. Plus what? Plus 1. So this is what we have as our Tn. So we want to see, guys, if this is true, that we are given n plus 1 squared, guys, it means our Tn is positive. There is no way that you substitute, guys, any value, n plus 1 squared. This is positive. Put any value of n here. As long it is in a bracket, then you will square it at the end. It will be positive. So meaning to say, n plus 1 squared is always what? Is always positive, this one. It will be always positive. Try any value. Is always positive. Try any value, guys, that you want from your calculator. Just put any value of n, then you square it. So if you have got a positive value from this is positive. Then we add a 1. Let's say we've got a 10. Then we add a 1. Are we going to have a negative value? No. This will be again positive. Let's say this n plus 1, whatever, it gave us a 25. Then we add a 1, this one. Are we going to get a negative? No. It's going to be positive. Whatever value that is positive, you add a 1, you are going to obtain what? A positive answer. So adding a 1 does not affect the positiveness of our expression. So that is the condition. So here, adding that 1. Adding 1 will not affect anything. All right? So it will result in a what? In a positive. So adding a 1 will result in a positive value as well. In a positive value as well. So therefore, our Tn is positive. All right. For all values of n that you're going to have as we are having this, the terms will be positive. So therefore, our Tn is what? Is positive. All right. For all values of n. Here they said what? Prove that all terms of the pattern are positive. So that is it. Our Tn is simply what? Positive. All terms that you're going to have. Because this is positive, and that's a condition that you can actually have. So all the terms will be positive. T1, T2, T3, T4, any one, and so on. So you see, guys, how you play around with this to prove that the terms, they can say sum of terms, maybe for another type of a sequence, they will talk about sum of terms. You work from the sum of terms. Here it was from the terms, or like Tn, from the Tn formula. Show that all terms, the terms T1, T2, T3, as they are separate. So you have to find that quadratic, then reason with it to say what are the conditions that will be positive. So this type of equation is usually on a factorization, which is going to give you a perfect square where you add a 1 or you add another value from a perfect square. So a perfect square expression is always what? Is always positive. That is the condition. All right, let us consider the other part, which is 2.3. We are given, consider the geometric series. Already you're told, guys, this is what a geometric, already told that. For values of p which is not equal to, p cannot be equal to what? Cannot be equal to 3. 2.31, determine the values. It's not a single value, but values of what? Of p, for which the series converges. Remember, the converging part of a series is that part which happens on the sum to infinity, where our R is greater than -1, but less than what? But less than 1. So that is the condition that you simply needed there. You must have R, then from that R you can play around with that converging part, all right? So 2.31, our R must be greater than -1, but less than 1. Do we have that? Yes, we can find it. This is T1, this is T2, this is T3, and so on. And R is simply second term over the first term from Tn over T of n minus 1. So we can simply play around that. What is our T2, the second term? We take this part as it is 3 over 4 into P minus 3 squared over what? Our T1, which is 1 over 2 into P minus 3. So let us divide 3 over 4, divide by 1 over 2. That's 3 over 4. Then we're going to divide by what? 1 over 2 like this. It is going to give us 3 over 2. So that's 3 over 2. Then these brackets, P minus 3 into P minus 3 squared. Gonna cancel and we remain with what? P minus 3. One bracket of what? Of P minus 3. So that's our R. And this R must be greater than 1, but less than 1. So let us simply substitute that. 3 over 2 into what? Into P minus 3 is greater than -1, but less than 1. So we can find the values of what? Of P from there. All right, let's get rid of the product. Here there's a product, 3 over 2. So I have to divide by 3 over 2 here. I have to simply divide by what? 3 over 2. Dividing by 3 over 2 is simply multiplying by 2 over 3, both sides, or simply divide by what? 3 over 2 as it is. Divide here by 3 over 2. So -1 divided by 3 over 2 is going to give us -2 over 3. All right. If you divide -1 over what? You have, open a bracket there, then we have 3 over 2 like this. So this is going to give us minus 2 over 3. All right, so this and this will definitely cancel. You've got P minus 3 less than 1 divided by 3 over 2 is just going to give us this, but as a positive 2 over what? 2 over 3. We want to solve for P. So what is affecting our P is the negative 3. So get rid of the negative 3. How can we get rid of the negative 3? We must add both sides of our inequality. Add 3, add 3. All right, so that was it. You are going to remain with what? P. So P is greater than, you add 3 on minus 2/3. All right, minus 2 over 3 plus 3 is going to give us 7 over 3. So this is 7 over 3 is less than 2 over 3 plus 3. All right, 2 over 3 just going to need to be a positive like this. That's 11 over what? 11 over 3. So that's the condition. So these are the values of P in within this interval. But in within that interval, P cannot be what? P cannot be equal to 3 from what we're given. So that is in within this interval that we're given. That is where you're going to have your P. Any value that lies there, but P cannot be equal to what? P cannot be equal to 3. So that's geometric. I already told that it's geometric. Then if the sum to infinite of this series is 1, exactly supposed to be that, because you're told that it converges. So you're dealing with what? Sum to infinite, where the series converges. You're dealing with a condition of what? Of a sum to infinite. This is the condition, remember. So we are given that the sum to infinity is what? All right, let us consider that we are given this 3.2 2.32. All right, the sum to infinite is 1. Determine the value of P if the sum to infinite is 1. All right, how do you find that sum to infinite? We saw that from our formula. The sum to infinite is A over 1 minus R. So A being T1, the first term. So A is equal to T1, our first term. And that is given. We have it. Half of P minus 3, guys, we have got that. So simply substitute into the formula sum to infinity, which is what? Which is 1, is equal to A, our A, that's our first term, our T1. That's half of P minus 3 over what? 1 minus R. So that's 1 minus our R. Remember, our R, we determined it here from T2 over T1. That was our R. This 3 over 2 into P minus 3. 3 over 2. So that's 1 minus 3 over 2 into P minus what? Into P minus 3 like this, all right? So this is what you have, and you have formed an equation from this. That's an equation where you must solve for what? Where you must solve for P. But how can we solve for P in this case? All right, let's just try to play around with our question here. I'm just gonna, just for the issue of space, I'm just gonna continue this side. All right, so this is same as over 1. So I can easily cross multiply. This multiplies here, this multiplies here. So 1 multiplies this. It's just going to remain as it is, 1 minus 3 over 2 into P minus 3. All right, is equal to 1 multiplies this side. So it's going to be 1 over 2 into what? Into P minus 3. All right, so this is where I am. I can simply expand the bracket. The bracket's actually the first part of P minus 3. Here has to be affected by minus 3 over 2. And there is a P minus 3 here, of which I could have just collected these as like terms, guys, in an easier manner, because these are like terms. Instead of expanding brackets like that, guys, I'm not saying expanding bracket like that is wrong, but you could have just taken it like terms like this. All right, you take this to the other side, it will be a positive. So it will be like this: 1 over 2 into P minus 3 plus 3 over 2 into P minus 3. Since these brackets are the same, they are like terms, so you simply add 1 over 2 plus 3 over 2. So it was going to be 1 over 2 plus 3 over 2, that's a 2. All right, it's going to be 4 over 2, which is 2, into P minus 3. So you then equate it to what? To that one that is remaining. Still, you're going to have same answers. But what I'm simply saying, all right, 3 over 2. Yes, it was going to be 3 over 2. Then you simply have to add. So it was going to be, yes, you're simply going to have the same answers because this was going to be 2p and minus 3 and minus 6. You see, but if let's say you wrote it this way, I'm not saying it's wrong. You can expand it even like this. There are so many ways. So from here, you're just gonna multiply, multiply here, multiply here, multiply here. All right. So let's see. 1 minus 3 over 2 times p. That's minus 3 over 2p. Minus 3 over 2 times minus 3 was gonna be positive 9 over 2. All right. And this is equal to 1 over 2 times p, that's 1 over 2p minus 3 over 2. Then from there, you have to collect like terms. So you see, it was just going to be lengthy work, but we could have done it in an easier way. Anyways, let us see. Collecting like terms, 1 and 9 over 2, 1 plus 9 over 2 is what? 11 over 2. So this is going to give us 11 over 2 minus 3 over 2p, which is equal to half p minus 3 over 2. So collecting our like terms, we can take this to the other side. It's going to be minus half. So minus 3 over 2 minus half, minus 3 over 2 like this. Then we're going to subtract a half. That is going to give us negative 2p. So that's negative 2p equal to 11 over 2 to the other side was going to be a negative there. It was going to be a negative. So it'll be minus 3 over 2 minus 3 over 2 minus 11 over 2 minus 11 over 2, which is negative 7. So this is equal to negative 7. Then find the value of p. This is simply a product here. So negative 2, negative 2. So p was going to give us a positive 7 over 2. So that's the value of p. So you see, guys, it was just going to be one and the same from that one that I used here, where you consider these brackets as like terms. Then you add the coefficients. You're going to obtain the same thing. 2 times p, that's 2 times this negative what? Negative 6. Then negative 6 to the other side was going to be positive. So 1 plus 6, that's 7 equal to 2p, divide by 2, divide by 2. So p is equal to 7 over 2. This was going to be a little bit easier when you collect these two brackets. When you take this bracket to the other side, it was going to be easier because you're going to have this. It was going to be like this, of which that's easier to solve. I'm not saying working with this part of where you have to expand the bracket, then collect your like terms, solve for P is wrong. No, guys, this is maths. Remember, I always say in mathematics, you are not supposed to be limited. There are so many methods, so many ways. All right. So if there's any other way that you do understand, guys, that's where you've got our community section. You can even upload the picture of what your calculations on the community section so that we can look into that to verify if whatever that you're doing is correct. Because some of you might have other methods, but that method, there is somewhere where it is applicable, somewhere where it is not applicable. So it is always good to verify. You have the community section is for you guys. So let us utilize that to our advantage. All right, let us utilize that to our advantage in terms of our revisions. Besides comment section, visit the community section. That is very, very important. It's very, very important to do that. So moving on to question number 3, we have got 3.1. If we are given this summation and we are given that it is equal to 59,046. Determine the value of n, right? And that was 5 marks. All right, so you are to ask yourself that what is the summation all about? It is simply sum of what? Sum of terms. So if it is sum of terms, let us figure out the type of series that was being, like the terms that were being added to form a series. They were taken from what? Is it arithmetic or is it a geometric? From these exponents, 3 to the exponent of what, guys? You can see this was taken from what? A geometric. This is the one where Tn is AR to the exponent of something. So that's actually was a geometric, and its sum of terms can be taken from this formula. All right. So that was the condition. But if you're not sure enough, then find the terms T1, T2, T3, then divide. But we can simply see that this is what? A geometric. It is what? A geometric series. So if it is a geometric series, our terms, in order for us to find the sum of terms from that formula, we saw that it is going to be a into r to the exponent of n minus 1 over r minus 1. So we are given the sum. This is our sum. Our Sn is equal to what? 59,046. We have that one. So what we are going to need is to find the value of n. All right. So let's figure out the terms. The first term, which is our T1, that represents the value of a. All right. Our T1 is equal to a condition where k is at what? Where k is at 2. When k is 2, you substitute your k there. So it's 2 into 3 to the exponent of 2 minus 1. All right, and that was going to give us a 6. All right, 3 times 2. All right, or just use your calculator. 2 into 3 to the exponent of what? 2 minus 1. All right, that was going to give us a 6. All right, that's our first term. Our second term, when our k is from 2, we move on to 3. When k is what? When k is 3. That was going to be 2 to the 2 into 3 to the exponent of k, which is 3. So that's 3 minus 1 like this. And that was going to give us T2. All right. Let's substitute here. Just put a 3. And that was going to give us 18. So you're going to do that, guys, for the other term. If you want to prove, you do that for T3. When this k is 4, you're going to substitute a 4 here. Then you're going to see that is going to give us what? 54. So that's 6, 18, 54. This forms a geometric. They have got a constant ratio, but we have discussed about that here. So you're not going to actually need all these terms, just T1 and T2, so that you can find your constant ratio, or the common ratio R, which is T2 over T1. And that's 18 over 6. And that was going to give us what? That was going to give us a 3. So having our R being equal to 3, and our first term, our A is what? Is 6. So that's our first term. So our R is 3, and our A being equal to T1, it is equal to what? It is equal to 6. So let us use our formula to find the value of n. You're going to need all these calculations. All right. Then you use your Sn formula to determine the sum of terms. So in our case, our Sn, the sum, you can write you can start with this formula. It is up to you. All right. And also for this n, all right, let's talk about n here, because this n is on a basic formula when you know how many terms do we have, like. But in our case, let's say we are given a summation like this. This is 10 and this is 2. How many terms do we have representing n? It's going to be upper minus the lower, 10 minus 2 plus what? Plus 1. So that is going to give us 8 plus 1, which is 9. So if we have got n in this case, and our starting point is 2, so meaning to say the number of terms was going to be given by upper minus lower n minus 2, all right, plus 1. The upper is n, the lower part is what? Is 2. So you subtract, then you add 1. Just like what you're going to do if there's a 10, there's a 100, whatever that you're given. So at the end, these will be number of terms. All right, so that's n minus 2 plus 1, which is going to give us n minus 1. Minus 2 plus 1, that's minus 1. So this is for our number of terms. It is given by what? N minus 1. This part here where you're going to find your n, you are going to substitute that as what? N minus 1. So be very careful about that, about the number of terms, all right? So that when you substitute here, your sum of terms, 59,046 is equal to A, the first term, our A is what? Is 6, into our R, which is 3. So that's 3 to the exponent number of terms, any number of terms. Remember, we talked about number of terms. It's what? N minus 1. So be very careful about that. All right. Then you're going to subtract 1 here over what? R minus 1. Our R is 3. So that's 3 minus 1. So from this equation, find n or solve for n. By doing that, you are done. So that's 59046 is equal to, divide these two together. That is going to be 6 over what? 3 minus 1, which is 3. So that's 3 that you're going to have into 3 to the exponent of n minus 1 minus 1, like this. All right, so this is a product. You can get rid of this 3. Simply divide by 3 both sides of your equation. So that means you're going to remain with 3 to the exponent of n minus 1 minus 1 equal to what? Let's divide here. That was going to give us 59046 divided by 3. That's going to be 19,682. 19,682. All right, let us find our n here. There is a negative 1. Let's get rid of this to the other side of the equation. It's going to be positive 1. So 3 to the exponent of n minus 1 is equal to 19683. All right, which we can write in the base of 3. Just on your calculator here, plus 1 is equal to, then this is what you're going to do. Press shift, then fact. Shift, fact. It gives us 3 to the exponent of what? 9. So in the base of 3, it is the same as 3 to the exponent of 9. This 19,683. So if we've got same bases, we do understand that when the bases are the same, the powers of these exponents will be exactly the same. So therefore, we are going to have n minus 1 being equal to 9. You equate the exponents. So thus, n is equal to what? Minus 1 to the other side is going to be plus 1. So our n is equal to 10. Thus, the series that we are given there, that summation, you've got what? 10 terms, all right? Like determine the value of n. Our n there is 10. Not to say it has got 10 terms, but at the end here, the last part representing your n is what? Is 10, all right? So that was the condition of this question. Just go through the formula. If it was arithmetic, you use the formula for the arithmetic, all right? Just like that. Let us move on to the second part of question 3, which is 3.2. There we are given information, the diagram here. Then let's see. They are saying an equilateral triangle RST with size 12p units is drawn. So guys, make sure that you download the PDF so that you can properly see. So RST is an equilateral triangle. This bigger triangle RST is an equilateral triangle, meaning to say these sides are equal. All right. And each side is given as 12p, 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 like that. All right. And remember, an equilateral triangle, it follows that the angles inside will be what? 60 degrees each. So this is 60 degrees, 60 degrees, 60 degrees each in terms of the angles. All right. Anyways, they are saying here, a second triangle is drawn by joining the midpoints of the sides of the first triangle RST. So the midpoints, that's halfway. So this second triangle that we see inside was drawn by joining the midpoint. So this one is a midpoint, meaning to say the distance will be now divided into two. If this was 12p, divide by 2. So that will be 6p here. This will be 6p. This will be 6p. Thus, this side here is going to be also 6p because whatever that you're forming here will be also an what? An equilateral triangle. Since this angle is 60 degrees, this will be 120 divided by 2. These two are equal, remember, so it also be 60 degrees, 60 degrees. Thus, you're forming an equilateral triangle by doing that, which will be also 6p. This side here is going to be 6p. This will be also 6p. This will be also 6p, like that. All right, half of what? Half of 12p, half of that. So that's the second triangle. Then each triangle thereafter is drawn by joining midpoints again of the sides of the previous triangle as shown on the sketch, and this continues indefinitely. So thus the next one was also from these midpoints. So if you find the midpoint, like you're now at the midpoint, it's now half of 6p, which is 3p. So that's this side is going to be 3p, this will be 3p, this will be 3p. So these sides will be 3p, 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 like that, of the triangle that enters, that is inside, like that. So this is the condition actually that you were going to have at the end. All right. So that was the information actually. From that information, the first question here was 3.21. Write down in terms of P. Your answer must be having P at the end. The length of each side of the second triangle, the length of each side of the second triangle, all right? The second triangle, guys, remember it was joined at midpoints. We've already talked about this, meaning to say the length is going to be what? 6p. That's why they said write down. You're not calculating anything here, guys. It's just to write down. So that's 6p what? 6p units, all right? Then 3.2 to calculate now in terms of P, the perpendicular height of triangle RST, the perpendicular height, triangle RST. Remember triangle RST, that's the big one, this one. They want the perpendicular height. So it was going to be like this. Triangle RST, this is RST. Remember, it is an equilateral triangle. So if I divide it into two equal parts, this line is a line of symmetry, which is also a perpendicular bisector. So that's our perpendicular height. So we need to find this perpendicular height. All right. Remember, each side is given by what? 12p, 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 each side. So this is 12p, this is 12p. But this base is now divided into two. The perpendicular bisector, remember this perpendicular divides into two. So that will be 6p, 6p, half of 12p. So you can work with one of the triangles, one of these, because they are actually the same, congruent. First triangle and the second triangle, it is up to you. So working with the second triangle, guys, is just like this. It is just like this. All right. You're just taking this part. You find H in terms of what? In terms of P. So focusing on this triangle, anyone, guys, you can focus with the second triangle. It's up to you. You can simply apply your what? Your Pythagoras theorem here. Since we have got this in terms of P and this in terms of P, it follows that the hypotenuse squared in this case from Pythagoras theorem. All right, from our Pythagoras theorem, it follows that the hypotenuse square, the square of the hypotenuse, 12p squared, is equal to the sum of the shorter side, the square of the shorter side, that is 6p squared, the square, plus h squared, our perpendicular height, which is h. So what we need is to find h in terms of p. All right, so let us find h in terms of p. This is same as 12 squared, that's 144, p squared equal to 6 squared, that's 36, p squared plus h squared. So take the 36 to the other side, that was going to be a negative. So that's simply 144 minus 36, and that was going to give us 108. So 108 p squared is equal to h squared. Remember, you need to find what? H, the perpendicular height. So introduce the square root. So therefore, our h was going to be equal to the square root of 108 times the square root of what? The square root of p squared. If you are to separate that square root, that's the square root of 108. We can determine that square root of 108 is 6 square root of 3 in simplest form. So that's 6 square root of 3. The square root of p squared, remember square root and the square neutralizes, so you're going to remain with what? P. So that's our perpendicular height in terms of what? In terms of p, our h is equal to 6 square root of 3 times what? Times p units. All right, that's our perpendicular height of that triangle RST in terms of what? In terms of p, as we are given, guys, in terms of p. So that was 6 square root of 3p, like that. All right, from our Pythagoras theorem, we can simply apply that one and so on. So that was it on 3.2, 3.22 to determine the perpendicular height. Then show that on 3.23, show that the sum of the area of all the triangles, sum of, all right, of these triangles formed will not exceed this, the sum. So this is under a condition of a series now, guys. Sum of terms. So there we need a series for sum of what? Areas. Our terms are the areas, all right? So that is, you must work with the areas. Let us find the areas first, then it's going to make sense after that. All right, so that's 3.23. Since we are dealing with the sum of what? Of areas, let us determine those areas. All right, the area of the first triangle in our case, what we're going to need is the area of the first triangle. All right, there we could also have used trigonometric ratios, guys, to find this, because remember, this is 60 degrees, this will be 30 degrees. You can also use trigonometric ratios, all right, just for revision purposes. All right, let's find our areas. Like I said, we're going to need the area of the first triangle. All right, let's consider the first triangle area of the first triangle, which is RST. All right, remember, area is given by half of the base times what? Perpendicular height. So it's gonna be half times the base. The base is our RS, the whole line, 6p plus 6p, which is what? The 12p, the whole line of RS. That's our base. So that's half of 12p times the perpendicular height is the one that we calculated. Remember, we calculated and got 6 square root of 3p. So you're going to multiply this. Use your calculator, guys. That's half of what? That's half of 12. Half times 12 times 6 times the 6 square root of 3. So that was going to give us 36 square root of 3. So this is 36 square root of 3. 36 square root of 3p. There's a p there. So you're going to remain with a p. So that was the area of the first triangle. Then the second triangle, remember, it was drawn at midpoints. So what is going to happen is that it's going to follow the first triangle just at midpoints. So meaning to say, in our case, this is our second triangle like this. It means the base here will be half. All right. This is our second triangle. This is the base. So the base here is what? Is half of 12p, which is 6p. It's just at half. So it will be 6p. So it follows that even it's perpendicular, this second triangle, the perpendicular drawn going down there is what? Half of this perpendicular of the first triangle. Everything is at half. So half of what? 6 square root of 3p. That's half of 6 is going to be 3. So it was going to be 3 square root of 3p. That's the second triangle. It simply takes from the first triangle, but with what? With a half. It's a half of that. So that was going to be the condition that will give us what? The area. So here we're going to need area of the what? Of the second what? Of the second triangle. From the same formula, guys, half base times perpendicular height. So that's half times the base, which is 6p, times the perpendicular height. This time it will be 3 square root of 3, half of what we had before. So that was it. Use your calculator. That was going to be half of 6 times 3 square root of 3. 3 square root of 3. And that was going to give us 9 square root of 3. So this is 9 square root of 3p. This is area measured in what? Square units. So it's just square units for what? For area. Then you're going to do the same for area of what? The third triangle. Remember, we want to form a series from these areas, sum of areas. So we are going to add them, then see what type of a series are we actually forming. Is it a geometric or is it an arithmetic? So the third one that is following, guys, it's a half of the second one. Remember, they were joined at midpoints. So that triangle that we are seeing here is joined at what? 3p, which was half of what? Which was half of 6p. So its base is 3p. What about its perpendicular height? It's going to be half of this one. Half of what? 3 square root of 3p. So it was going to be 3 over 2. 3 over 2 square root of 3p like this. This is our perpendicular height. Then we can determine its area just like what we had before. So it's half times the base, which is 3p, times the perpendicular height, 3 over 2 square root of 3p like that. This was going to give us the area of the what? Of the third triangle, half of 3 times 3 over what? 3 over 2 square root of what? Square root of 3. This was going to give us 9 over 4. It's actually 9 over 4 square root of 3. 9 over 4 square root of 3p times p. So that's times p square units. These are our areas from the triangles that we can see. The other one was going to be half of that, like, and so on and so on. So forming this, it's a series of areas now to say the first area and so on. So sum of what? Of areas. We want to see what is happening. The first area, it was 36 square root of 3p. The next one, it is 9 square root of 3p, followed by 9 over 4 square root of 3p like that, and so on and so on. This is the one that you're having. It's actually sum. Let us add here, since we are dealing with what? With the sum of terms. So this is plus, 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 and so on and so on. You're going to add. So this series that we have formed, guys, they are saying we are supposed to show that the sum of all areas of the triangle formed will not exceed. So what we simply need here is to find that sum, determine that sum, Sn, and see what we are going to have in terms of n. Is it going to be limited to this value or not? But in order for you to have the sum of terms, you must know the series that you're dealing with. Is it arithmetic or a geometric? So by looking here, guys, you can see this is geometric. You cannot add and like there's no common difference here. But let's check the common ratio to see if it is truly a geometric. T2 over T1, that's T2, this is T1, T2, T3, and so on. And so on and so on, all right? So T2 over T1, that's 9 square root of 3p over 36 square root of 3p. This is going to cancel. You remain with 9 over 36, which is 1 over 4. All right, let's prove with T3 over T2. Our T3, that's 9 over 4 square root of 3p over our T2, 9 square root of 3p. This one and this one cancels. 9 over 4 divided by 9 is going to give us 1 over 4. So truly it is a geometric because we have got what? The constant ratio throughout. So with that constant ratio, we can prove that, all right? Also, it is 1 over 4, all right? I want us to see something. When your constant ratio is 1 over 4, let's go back to our formula sheet. Remember, under a geometric, if R is in within this interval, -1, 0, 1, in within, when it is a decimal, it's minus a third, it's 1 over 3, 1 over 4, 1 over 5. As long they are fractions, there's those decimals, 0, something from 0 to 1, up to a number that is less than 1, from 0 to -1, in between. It lies under a what? A sum to infinity. Any other, if it is 2, 3, 4, and so on and so on, if you find your R is 2, 3, it's no longer under sum to infinity. But if your R is in within this, it means we are dealing with what? A sum to infinity. And 1 over 4 is actually greater than -1, but less than 1. So meaning to say, we are dealing with what? A sum to infinity in our case. That is the condition of our R here. It is what? 1 over 4. So if our R is greater than -1 but less than 1, it means you're going to calculate what? Sum to infinity. Our Sn represents sum to infinity of a geometry, which is A over 1 minus R. So let's find that one and see, because it is all about the sum. We want to see if that sum is going to be equal to this. Then we know that it cannot exceed that. So it's all about finding the sum. All right. So A is what? The first term, T1. That's our A, which is 36 square root of 3p over what? 1 minus R. Our R is 1 over 4. So that is the condition. So our sum to infinity, which is representing the Sn, our sum is what? Simply divide this part here and see what you're going to have at the end. So that is going to be 36 square root of what? Square root of 3, like this. All right, I forgot just to put it. Okay, it's fine. Over 1 minus 1 over 4, like this. It is going to give us 48 square root of 3. So that's 48 square root of 3p. That's our sum to infinity. So truly, that's the area cannot exceed this part. All right, there we have got our A. Our A, guys, let's see, guys. Am I the one who just left? All right, I'm the one who just left this P squared. There was a P and a P. I think someone like, what is happening? There was a P squared throughout here. P squared. Sorry for that, guys. Can we correct? A P squared throughout. P squared, P squared. This P and P, P and P, P and P. So that was going to be P squared, P squared, P squared. Can we continue with that? P squared, P squared. Very sorry for that. So meaning to say this is a P squared here. This is a P squared. So you can simply have that slight errors in exam. Guys, be very careful. So as you can see, it is exactly this one, the sum to infinity that we are given there. So thus, the sum of areas of all triangles formed will not exceed that. All right, so that's here. The sum of areas, all right, the sum of areas of all triangles, formed will not, all right, it will not exceed what we are given here, 48 square root of 3p squared. So guys, can we just correct that part where I left the squared? It's supposed to be p squared, like that. So that's how you can play around with this. Simple like that. All right. That's how you can play around. It was all about the areas. So you're just playing around the given diagram. All right. You must be very, very careful. Like in playing around, sorry for that. In playing around with this information, you must be very, very careful. Your your simplification there. All right. Anyways, that was it. That was it. Let us consider the other part, question number 4. We are given f of x, now part of our functions. The graphs f of x is given as ax squared plus bx plus 15 over 2. And there is a gx, which is x squared plus 2x. They are being sketched, f and what? F and g. All right, so we can see our f here and our g, this one. So the gx is the one that we are given. Its equation, that's x squared plus 2x, where f of x is incomplete actually. All right, but there we are given that there are points A and B, the x-intercepts of f, all right, A and B, all right, that's here and here. Those are for f, all right. Then the point C and this O, they are now the x-intercepts of what? Of G. Then there's a point D, that is the turning point of what? Of f. All right, so D, this one, it is the turning point of F. Yes, that's a turning point here. And we can see that it is in the same line. This is a vertical line that we are having same value of X to this point E, which is also a turning point, but this is a turning point of what? Of G. All right, it's a turning point of G. All right, so that was it. Then with this other information, we are given that 4.1, that is the first part. Let's see what we're given here. All right, so 4.1, we are now given, write down the coordinates of what? Of point F. Point F. So where is point F? Point F is here the y-intercept in the y-axis, right? So it is the y-intercept of what? Of f of x. So that's simply from our f of x, the y-intercept is what? 15 over 2 when x is equal to 0. So that's 15 over 2. So that's what you are going to have on 4.1 f when x is 0 in the y-axis. Remember, x is 0 there. Y is going to be 15 over 2. So it follows that from f of x being given as ax squared plus bx plus c, c is the y-intercept. So that is the condition. All right, so 4.1 was direct. Then 4.2, determine the coordinates of what? C, for 2 marks. All right, so remember we talked about C here as the x-intercept of what? Of G. So we can use our gx because C is what? The x-intercept there. So that's the x-intercept of what? X-intercept of what? Of G. Where we have our gx as x squared plus 2x. So remember, x-intercept, y is supposed to be equal to 0 in that condition. So simply x squared plus 2x must be equal to 0. You solve for x because it is what? X-intercept. So factorize x. That's going to be x plus 2 is equal to 0. So x is equal to what? To 0, or 2 to the other side is going to be a negative. So that's 0 here on the origin. and minus 2. So minus 2 is the one at C, this one on the negative side. So therefore, the point C cannot be 0, but it's going to be what? Minus 2, 0. All right, so that's our point in C, minus 2, 0, just like that. Okay, so you see, guys, easy like that. You can answer these questions. 4.3, the turning points of F and G lie on the same vertical line DE. And we actually noticed that this condition, they lie on the same vertical line DE. All right. So what is the condition there? 4.31, determine the value of P. For 1 mark, the value of P. Where can we have the value of P? We can determine the value of P since it is the X value. P represents the X value here, P. It is the X value at the turning point. It is the same X value at the turning point of E. We have got the same value of X throughout. X is the same here. X is what? Is the same throughout on this vertical line. Just like the line, this y X is equal to 0 throughout. So that is the condition of a vertical line. So if X is the same, instead of using f of X, because on f of X, it's not complete. We do not have A, we do not have B. So use what? Use GX. All right. So simply use GX. All right. So to find the value of P, that's simply X value. That's the X value at the what? At the turning point, that P. So you can use what? GX. So from our GX, remember the X value at the turning point is taken from the formula minus B over 2A. So you can use your GX. This is your A and this is your B. So that's going to be minus our B, the coefficient of X, that's 2, over 2 times A, the coefficient of X squared. So that was going to be minus 2 over 2, which is minus 1. So the X value at the turning point is negative 1 here. The X value is negative 1. Thus, the value of P, the P represents what? The value of X. So therefore, P is equal to what? Negative 1. All right. So that was the condition. That was the condition. That was the condition. All right. Then after that, the length of DE, 2 marks for that. All right, we can determine the length of DE, guys. The reason being that if you're given to calculate the length, all right, this is a vertical line, remember, DE is a vertical line from D to E. So the distance DE is simply the Y value at D. You just take the Y value at D and you take here the Y value at E. The difference, or just like y1 minus y2, the difference between the y values. If it is a horizontal line, you work with x values, all right? You're going to have x1 and x2, whatever that you have, the difference between the x values for a horizontal line. But this one, it's a straight vertical line. You work with the y values. So you're simply going to need the y value at what? At D, the one that is on the top. It's just like top minus what? Top minus the bottom. So the y value at D minus the y value at E. Top minus what? Top minus the bottom. So that is the condition there. So what is the y value at D? We have it. The point D is given as P8, where P is minus 1. But the y value, y is what? 8. Minus 1, 8. This is the y value. We have that one. The y value at D is what? Is there. So what are we going to need here is what? The y value at E. So to find the y value at E, it is simply when x is minus 1, you substitute in what? In gx, because E lies on what? E lies on what? On gx. So this will be taken from what? From G. So the y value there, when x is minus 1, substitute in gx. That's minus 1 squared plus 2 times minus 1. All right, so that was going to give us 1 minus 2, which is negative 1. So that's the y value at E here. The y value at E, it means point E x is -1, y is -1. This is what I'm trying to say. You have the x value, the y value. So you simply have to substitute the x value into gx. That's it. Then you can have your length or distance between these two from a vertical line. Just subtract y values. So the y value at D is what? Is 8 minus the y value at E, which is -1. So negative, negative, that was going to give us what? A positive. So therefore, the length of DE is 8 plus 1, which is what? Which is going to give us 9 units, all right? So if you're going to have this, we are going to have 9 units at the end. That's the length of the given line DE, just like that. Or you can use points now, the distance formula. All right, that's another way. Since you have got the point D, the point D is -1, 8, and the point E, remember, x is what? -1 and y is -1. So you can use the distance formula to say dE is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, from that part of your analytical geometry that you apply in paper 2. Yes, still you're going to have the same answer there. All right. Anyways, let us see what you're given. Show that A is -1 and B -half and B is -1. All right. How can we show this? Where is A and B? A and B, they are found on what? F of x. So let's take our f of x and try to reason with that. If we can find the values of A and what? If we can find the values of A and B. All right, so that was our 4.4. We need to show that A is equal to -half and that B is equal to -1. And these are from what? These are from f of x, where our f of x, that function, remember, it's given as ax squared plus bx plus 15/2. That is our f of x. So what can we do, guys? What can we do? This function, we only have, what is that we have? We have got this turning point, of which, this y-intercept, of which is this one that is already on your function, on that equation. So it will be difficult for you to utilize this as it is. All right. But since we have a turning point from that f, remember, we have what? A turning point. So what we can see is that we are given a turning point, all right, and a point, which is the y-intercept, and a point. That y-intercept, this one, it's a point. Remember the coordinates of f, we calculated this and we stated this and they said it's what? 0, 15/2. So these two, they are enough to give us the equation of a what? Of a parabola. We are dealing with a parabola, a quadratic. So remember, from a turning point and a point, it follows that f of x is given as a into x plus p squared plus what? Q, when you are given a turning point, where minus pq represents the turning point, where in this case, where minus pq is the turning point. So in our case, we have got the turning point of what? At this point D. On F, we are talking about on F, our turning point is -1, 8. So when it is substituted into this formula, it follows that f of x will be equal to a into x plus, when it was a minus, this becomes what? A positive. So here we've got -1, it's going to change to a positive. So that's x plus 1 squared. Q is not affected. A positive Q, a positive Q. That's the value of y, which is 8, is not affected. So this is your f of x. You can expand this, but you do not have the value of a, so you'll be limited. So just find the value of a from the point that you're given. That's where the point, please, or any other point, which in our case, it is what? The turning point 0, 15 over 2 like this. You can use this point to find the value of A, all right? By substituting this, we have got the X and the Y value. So our Y value, that's what? 15 over 2. So 15 over 2 is equal to A into our x, that's a 0 there, so that's 0 plus 1 squared plus 8. You need to solve for what? You need to solve or find the value of A from there by substituting any other point that you're given. In our case, we are using the turning point. All right, so 15 over 2, we can even take this to the other side, this 8 to the other side. So it's going to be 15 over 2 minus 8. 15 over 2, subtract 8, that's negative half. Negative 1 over 2 is equal to 0 plus 1 squared, that's 1. 0 plus 1 squared, guys, that's simply what? That's simply a 1. All right, this is not even necessary, guys, to do this. All right, anyway, let me do this. So that's 1 times A, which is A. So A is equal to minus half, of which we have already proved that A is negative 1 over 2. So as the purpose of finding this A, it is because we need it here. We need it here on this f of x so that we can be able to expand. So therefore, our f of x is given as our A is what? Negative half into x plus 1 squared plus 8. But we cannot see the value of A, B, and C. Like from here, we can only see that our A is negative half. But what about B? In order for you to find the value of B, you must expand. Now you're forced to expand this and write it in the format ax squared plus bx plus c. That's where we can properly see our b, the coefficient of what? The coefficient of x. So you were forced to expand and simplify, expand these brackets. So our f of x was going to give us negative half into x squared plus 2x plus 1. If you expand this properly, guys, these are just two brackets. Expand these brackets properly. All right, plus what? Plus 8. So that's negative half times x squared. Negative half times negative 2, that's negative 1x. Negative half times 1, that's negative half plus 8. All right, collecting the like terms here is going to give us negative half x squared, negative x, negative 1 over 2 plus 8, which is going to give us 15 over 2. All right, this is going to give us 15 over 2. So from here, guys, we can tell what is our A, B, and C from there. Ax squared, then the coefficient of x, that's our B. So therefore, A is equal to minus what? Minus half, and our B is equal to what? Minus 1, the coefficient of x. So that is exactly what we can see even from that f of x. We can see from that f of x, we can see that our y-intercept is 15 over 2, exactly what we had before. So that's a verification to show you that you are on the right direction. So that is how these questions can sometimes be given, as where you're asked to find the values of A, B, and C. Try to expand that into the format. If we can have that format, then we are done. We can properly see the values of A, B, and C, of which there are so many ways, guys. Functions can be answered in different ways. It just needs time, guys. It just needs like for us to have a lot of time where we can talk about these functions in detail, like in detail. But anyways, that is what you had. All right, then let us consider the other part. Let us consider the other part, whatever that we determined here, guys. If you're gonna need it, just remember your values. All right, here they are saying determine the equation of the straight line joining the points of intersection of the graphs F and G. Round off your answers to 2 decimal places. I mean, if so, you're going to have decimals there. All right, the equation of the straight line joining the points of intersection of the graphs F and G. All right, the graph F and G, if we are to consider properly here, these are the points of intersection, this one and this one. So if we were to consider a line being drawn, and what we need is its equation like this. This was going to give us a horizontal line, isn't it, guys? By just looking into this, you are seeing that you're going to form actually a horizontal line. But anyways, for the points of intersection, we do understand that the two graphs will be equal at that point. All right, let's have this one. This was going to be a horizontal line, this one. It was not going to be that line that you can have, which is slanted y is equal to mx plus c. This is just a horizontal line, just like y is equal to 0. It can be y is equal to 3, y is equal to 2. So we simply need the value of y at the point of intersection of the two graphs. All right. So that was our 4.5. So that's 4.5 points for points of intersection. F of x must be equal to gx at the point of what? At the point of intersection. At the point of intersection, the two graphs, they are equal. All right, so f of x is given. Remember, we calculated a and b. We said a is what? Negative half, and our b was -1. We actually had this f of x here. This was our f of x, remember? So just take this f of x, equate it to gx. All right, that's the condition that you're going to have here. So that f of x that we calculated, it was minus half x squared minus x plus 15 over 2. So you must equate it to gx. And that's our gx originally given as x squared plus 2x. So we're gonna need to solve for x, then find the y values. You can see this is a horizontal line, so it must be given in the form y is equal to the constant value, which is the y-intercept where the graph crosses. But there is a need for you to solve for x, as you can see. All right. How can we solve for x? All right, let us just take these other terms to the other side. Since it's a quadratic, you must remain with what? A 0 there. So this was going to be x squared. Here was going to be minus x squared. Minus half x squared minus x squared is simply minus 1, minus half minus 1. There's a minus 1 here. So minus half minus 1, that's minus 3 over 2x squared. All right. Taking the 2x to the other side is what's going to be negative 2x. So minus x minus 2x. Simply minus 1 minus 2, that's minus 3. So that's minus 3x, all right? Then we are left with a constant 15 over 2, and that must be equal to 0. So you can solve this quadratic equation, or we can simply get rid of the negative here on x squared, the coefficient of x squared, as it is a negative. Simply divide by negative 3 over 2, negative 3 over 2 to get rid of the fraction as well. All right. Each and every term divide by negative 3 over 2. So that was going to cancel, and we have got positive x squared. Minus 3 divided by negative 3 over 2 is going to give us a positive 2. So that's positive 2x. 15 over 2 divided by negative 3 over 2 is going to give us a negative 5, and that's equal to 0. So this is what we have, guys. Let us solve for x. All right, so solving for x, we can see that they already talked about this rounding off to 2 decimal places. So meaning to say it is actually that part when it is on the quadratic equation. When you have to solve this, it must be to 2 decimal places, meaning to say your factorization was not going to work. Also, if we check negative 5, we do not have factors of negative 5, which adds up to 2. So factorization is out. You are only left with quadratic formula or completing of the square method, where x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a from our quadratic formula. So that's A, B, C there. So meaning to say x is equal to minus b minus 2 plus or minus the square root of b squared, 2 squared minus 4 times a times c over 2 times 1. So you can just use your calculator at once. Here, simplify everything at once. You have your x values, or you can simplify what is under the square root first. That's 2 squared minus 4 times 1 times negative 5, which is going to give us 24. So that's the square root of 24 over what? Over 2. 2 times 1, that's 2. So that is going to give us two possible values of x. Minus 2 plus the square root of 24, all right, over 2 like this. Then as a decimal, just fix your calculator to two decimal places. That's 1,45. 1,45, or our x is going to be, let's put a negative this time. This is going to be what? This is going to be negative 3,45. Negative 3,45. So for each and every value of x here, guys, anyone, because we are understanding that the x values, they are different. There's an x value on the negative region here, which is going to give us the y value. There's an x value on the positive region, which is going to give us a y value. For these values of x, we are going to obtain the same value of y because that's a horizontal line. So our equation, like I said, must be of the form y is equal to y is equal to. So you're going to take any value of these two, anyone. If you use 1,45, it's your choice. Minus 3, you're still going to see that the value of y was going to be the same. And you substitute in any one of these two functions, f of x or gx. So as for me, I'm going to substitute in gx. Substituting in gx to find the y value, all right, you're going to see that that was going to be the same. Remember, our gx is x squared plus 2x. So when x is 1,45, let us find the y value, 1,45 squared plus 2 times 1,45. This was going to give us, let us see, 1,45 squared, like this, you square it, plus 2 into 1,45. This is going to give us 5,00, which is what? Which is a 5. So that's the y value. Y is equal to what? Y is equal to 5. Even if you're going to use this negative 3,45, all right, let's prove with that one. Then you'll see that it is just the same. Negative what? 3,45. Negative 3 here. Negative 3 here. All right, like this. Negative 3. But I have to put a bracket here. Supposed to put a bracket like this. So you can see that we are obtaining the same value of y. For these values here, y is equal to 5. So if x is 1,45, y is equal to 5. If x is minus 3,45, y is equal to 5. What type of a line? That's a horizontal line, guys. You're simply told y is what? Y is the same. At this point, y is 5. At this point, y is 5. So throughout this line, y is equal to what? Y is equal to 5. That's a horizontal line created. So that was the equation of what? The straight line joining those. So therefore, the equation of the straight line is going to be y is equal to what? Y is equal to 5, just like that. So they can actually ask such typical questions, all right? You just have to be careful, study the diagram, the graphs that you're given, properly see your graphs, how are they presented. So that was it for 15 marks on a parabola, given these two parabolas. So download the question paper, guys, so that you can properly see these questions. All right, question number 5. You are given this time f of x is equal to, that's a log of x in base of a. There's a point q on the graph. All right, then from there we are being asked 5.11, determine the value of a for 2 marks. All right, the value of a we can simply substitute into that log. All right, since we've got a point, So 5.11, remember you're given our f of x being equal to the logarithm of x in base of a. So that's the log of x, all right? The log of our x from this point, this is xy. X is what? 1 over 4 in base of a is equal to y. What is the f of x? That's y there, which is 2. So remember, we can convert a log a in base of b when it is equal to c. It states that a is equal to b to the exponent of what? B to the exponent of c, this condition. So that's our a here, which is what? 1 over 4. So 1 over 4 is equal to a to the exponent of what? 2. We need to calculate the value of a, that's a square. Introduce what? The square root. So a is equal to what? The square root of 1 over 4, that's plus or minus 1 over 2. All right, so it's going to be plus or minus 1 over 2. But we do understand that a base here is supposed to be what? Positive. All right, so therefore our a is going to be 1 over 2. Okay, so that was the condition of our a. Then 5.12, determine the inverse of the graph of f and write your answer in the form y is equal to this for 2 marks. All right, the inverse, we can simply determine the inverse. Remember, our a is 1 over 2, so that means that our f of x, which is y, is equal to the log of x in base of what? 1 over 2. To find the inverse, you simply need to interchange first x and y. So you must interchange your x and y. Thus, x is equal to, if we interchange, x is equal to the log of y in base of a half. Then you simply make y the subject. Make y the what? The subject of the formula. So that's y here is equal to the base to the exponent of what? The answer. Our base is 1 over 2 to the exponent of the answer to the exponent of what? To the exponent of x. Just like here, rewriting in an exponential form from this condition, a is equal to b to the exponent of c. So that is how you can actually attempt this one. So that was our 5.12. All right, let us consider another part. There is sketch the graph of the inverse of f, showing the intercepts or intercepts with the axis and at least one other point on the graph, at least one other point. All right. So the inverse is easier, guys. This is our inverse already. We have got it here. But we do understand that the inverse of this graph is simply, all right, for any graph, actually, the inverse of any graph is simply drawn from what? From the reflection in the line y is equal to x, a reflection in the line y is equal to x. So if we are to reflect this graph in the line y is equal to x, it simply means you swap the values of y and x. That's a reflection in the line y is equal to x. You swap the values, all right? We do understand that for this logarithmic graph, we have got the point P. Even though it's not indicated, we know that it is 1, the x-intercept. When we are given this y is equal to 0 from our logarithm, we know that it is logarithm of 1 in any base, which gives us what? A 0. So the x value here is what? Is 1. So we swap that one. The point P is given as what? 1, 0. So let's swap that 1, 0. We swap, it's going to give us 0, 1. So meaning to say our inverse, it is going to be at the y-intercept 0, 1, 0, 1, maybe somewhere here. All right? That's the point 0, 1. And also, we have another point, which is what? Q. We have got the point Q, which is 1 over 4, 2. Let's swap these. It is going to be 2, 1 over 4. So there's another point, which is 2, 1 over 4. Maybe 2 is somewhere here for the x values. This is 1, 2, 3, and so on. So maybe 2 is here, then 1 over 4 can be approximately somewhere here. So we can see that these 2 points can give us the inverse when you join them. You're gonna just join these 2 points, this one and this one, like this. So this was gonna be the graph of what? The inverse. So that's our inverse. So this point is what? 2, 1/4. All right. And the y-intercept, which is what? 1. That's 0, 1. This, you just reflect those points in the line y is equal to x, swap the values, you are done. So that was the sketch. All right. When we have this one, guys, it's one of the easiest, the inverse. You can simply sketch it that way. With those 2 points, you know that, guys, the sketch is going to be the shape, like it's going to be like that. So that's the inverse. That's our inverse there. Then determine the values of x for which our f of x is greater than what? Greater than -5. All right, our f of x is greater than -5. This is our f of x originally from our diagram. I want us to interpret what is happening here. This is our f of x, and it is going in the negative region. So they are saying it is greater than -5. Let's say -5 is somewhere here. Let's say this is -5, like here. Let's say this is where we've got -5. It means y is equal to -5. So the values of x that will limit our f of x, all right, that's 5.3, that will limit our f of x to be greater than -5. Remember, these are y values, meaning to say you're talking about the y values as we are going up. 1, it is limited for the value of x in the y-axis, this one, because the y-axis is an asymptote. This graph of f of x cannot cross, or it cannot pass the y-axis at x is equal to 0. So we already have a limit. We have a limit there, an asymptote. So you must consider an asymptote that for x is equal to 0. All right. Anyways, let us determine our critical value so that we can conclude with that asymptote. Remember, that's a logarithm. We found that our a is 1/2. So f of x, that's the logarithm of x in base of 1/2, is equal to -5. For critical values, use an equal sign. All right. For critical values, you equate to that. So that's x is equal to, remember that conversion, log, you convert to exponential. A is equal to b to the exponent of c. So a is equal to b to the exponent of c. What is our a in this case? It is x. So x is equal to 1/2 to the exponent of what? -5. We convert it that way. So we can solve for x. And that was going to give us 32. This is the value of x. So I want you to take note what is happening, guys. Our x is limited from 0. It is supposed to be a value that is greater than 0. It cannot pass 0. So I talk about values of x going this side. But definitely for this y value that you're going to have at -5, it is definitely going to be limited to a certain value of what? Of x. Because already there's a limit for 0 there. So that 32 is a limit. So therefore, our x must be greater than 0, our asymptote. It cannot pass 0 for f of x, so it must be greater than 0. But as it is greater than 0, it will be going 1, 2, 3, and so on, up to what? Up to 32. So it must be less than 32. Not equal to, we do not have an equal to here. So you do not put that. So x must be greater than 0, but less than 32 for whatever value that will correspond. It will be in between that for our function f of x to be greater than what? To be greater than -5. So you play around that way. This is a logarithmic graph, one of the easiest, 10 marks. All right, that was actually for 10 marks. All right, let us move on. Another part, which is question number 6. The sketch here that we have, it shows, all right, we have got a hyperbola and a straight line, and that is given in this format. And this gx that we are given negative x, that's negative x plus k there. This here, this alone tells us that we are dealing with the axis of symmetry. Remember, for a hyperbola, it is y is equal to x plus k for a positive gradient, or y is equal to minus x plus k. As long this is 1 here, the coefficient is -1 or +1. That's the axis of symmetry. And we can actually prove it that it is the axis of symmetry because we can see that it passes through the intersection of what? The asymptotes. The asymptote here for x, which is what? -4. And this one for y, which is what? -1. This point D, it is for the asymptote. So that's actually the axis of symmetry with a negative gradient, that one. Axis of what? Of symmetry that we are given there in disguise with what? With a negative gradient. That was the condition. All right. So you just need to understand all those things because we are not even told about that, but you must know that it is what exactly is happening. Then the graph of f of x casts this point at what? A minus 8, 0, which is what? The x-intercept, that's the x-axis. All right. At this point A, all right. That point A here in the what? In the x-axis, no problem. Then the asymptotes, that is that at D, and this information G passes through the point D. All right, the point D, this one we talked about it, and meets F, then cuts. All right, no problem. This is our sketch, guys. So we can see that that is our sketch, and these were the questions, 17 marks for that. All right, let's see. 6.1. Determine 6.11 the value of what? Of k. All right, where is k? K is found from where? That axis of symmetry. So if you do not understand that it is an axis of symmetry, you are going to be limited now, because definitely we must take this solution from what? The axis of symmetry concept, to say that axis of symmetry, that axis of symmetry that we are given here with a negative gradient, whether it has a positive gradient, it passes through the what? The intersection of the asymptotes. So you're simply going to solve that if gx is equal to negative x plus k and passes through the point D, which is the intersection of asymptotes, we can solve for x by substituting the value of y, -1, and the value of x, -4. We can solve for k, right? So that's it, positive. That's to the other side is going to be -4. So that's -5 is equal to k. So k is negative what? K is equal to -5, all right? So that was the condition here of 6.11. Then 6.12, the values of A, P, and what? Q. A, P, and Q, they are found from f of x. So that's from f of x. So that's 6.12. You must determine the value of A, the value of P, and Q. So that's from what? From our f of x, that hyperbola, where f of x is given as what? A over x plus p plus q. Remember, guys, this from a hyperbola, when you're given in this format, the minus pq is the part of your asymptotes. So our asymptote is negative what? -4, -1. So when you were to substitute 4 minus 4 there, as you can see, it was going to be positive x plus. From minus, it changes to a plus. So p is a positive. So p is equal to +4. The q is not affected. Q as it is not affected. The y value is not affected. So our q is what? -1. It's not affected. All right. So that's, you can properly see the P and the Q from the asymptotes, right? But to find A, you must substitute this now back into your f of x. Since we have this, that's going to be x plus 4 minus 1. Since we have this, let us find A. In order for you to find the value of A, there must be a point. You must use a point on what? On f of x, which lies on what? On f of x. So is there any point? Yes. From our f of x here, there's a point what? There is a point A, which is our x-intercept. It lies on our f. Remember, that's the part of f again here. So we can use the point negative what? Negative 8, 0, or point A. That's we've got the x value, the y value. From that, we can substitute y is a 0. All right, y is a 0 when x is what? When x is negative 8. Then solve for A. That's it. You're done. All right, so let us solve for A. Minus 1 to the other side is going to be positive 1. A over minus 8 plus 4, that's minus 4. Cross multiply 1 times A, that's A. 1 times negative 4, that's a negative 4. So that's it. We have got the values of A, P, and Q. Our P, remember, that's 4, and our Q is what? Negative 1. So that's it. And that gives us f of x. Let us just write our f of x properly. Remember, it's A over x plus 4 minus 1. So that's our f of x, just in case if you are going to need this f of x, you're going to use that part. You are going to simply use that part that you have already determined or calculated before. All right, so you see, guys, it's just a play around. You play around with these questions. Then 6.2, determine the values of x for which f of x is greater than or equal to gx. F of x, all right? Remember, I talked about conditions, guys, where two graphs are given. Like in this case, we've got two graphs. And okay, let me just write the 6.2. And the condition is that f of x must be greater than or equal to gx. I said for this type of a question, you work with the intercepts, the way you have got the intercepts as your critical values. You must have critical values for each condition. So where our f of x is greater than gx, it means our f of x is found above gx, on top of gx. This is our f, all right? This is our f, the hyperbola. So where is it found above, on top of gx, on top of g? It is going to be from the point of intersection here. Those are your critical values. We can see from here going this side, our f is what? Our f is above g. It is found on top. G is going this side down. It's below, but f is above. If you check from here, this is our f is above, that's our g is going this side, all right? But it was from the negative because at that condition, our f was in the negative. But the moment we have this point here at point C, in between point C and the asymptote, you see that your f is now going up. This is your f, it's going up. At that moment, your g is below. This is your g, it is what? Below. So those are the two conditions that we are going to need. But in order for you to find these two conditions, as we can see, we need point E, because it's taken from point E going this side. This one is taken from point C in between this asymptote. So C and E are what? Those are points of intersection. Those are the critical values. The critical values are the what? Points of intersection for this type of an inequality. Check the videos on your functions. I've talked about different ways of finding such conditions where f of x is this, f of x is greater than that, this and that. So you need critical values first. And we do understand that the critical values, since they are at the point of intersection, it means at that point, f of x will be equal to gx at the point of intersection. So you take f of x, you equate to gx. Remember, this is our f of x minus 4 over x plus 4 minus 1. We equate that one to gx, and our gx, remember that is the one that you're given, minus k, minus x plus k. Our k, remember we said is what? Negative 5. Our k is negative 5. We calculated this one before, so that's minus x minus 5. All right, so that's minus x minus 5. So that's it. That's your f of x, and this is your gx. So we need to solve for x. How can we solve for x? All right, let's get rid of this negative 1. Let's take it to the other side. It's going to be a positive. So simply add 1, add 1. So you're going to remain with negative 4 over x plus 4 is equal to minus x minus 5 plus 1. That's a minus 4. All right. So here I can simply see that I can easily cross multiply, but before that, negative here is common, so I can simply factor out the negative. So these two brackets will be the same. These two will be the same, x plus 4. This will be x plus 4. If we factor out a negative, it's going to be x plus 4 over 1. So it will be easier. When you cross multiply, you know what you are dealing with. So it will be minus into x plus 4 into x plus 4. So that's minus x plus 4 squared. X plus 4 like this into x plus 4. So x plus 4 times x plus 4, that's x plus 4 squared. 1 times minus 4, that's a minus 4. There is a negative, there's a negative. These two can cancel. Guys, are you seeing what type of an equation are you left with? X plus 4 squared is equal to what? 4. So instead of you expanding these brackets, simply remove what? The square by introducing the square root. So that's this neutralizes. X plus 4 is equal to plus or minus what? 2, the square root of 4. So that's it. We can have our values of x from there. So x will be equal to 4 to the other side is going to be a negative, plus or minus 2 minus 4. So it's 2 minus 4, which is minus 2, or x is equal to minus 2 minus 4, which is what? Negative 6. So these points of intersections, guys, are our critical values. They will help us to solve the inequality. We need critical values. When you're solving this as an equation, say this is an equation. Yes, you can put that inequality the way that you understand, but critical values, this is equal to this. You have your points of intersection. So according to this, which is which here? Which one is minus 2 and which one is what? Minus 6. According to what we have, remember that's a 0 here, our origin. So just from 0, it means the first one here is going to be negative 2. So E corresponds to what? Negative 2 when X is negative 2. And negative 6 is going to correspond there at what? At this point C. At this point C, our x there will be equal to what? Negative 6. All right. Remember D it's here. D it's here, guys, before. Negative 4 it's here. So negative 4, negative 5, negative 6. That can actually make sense. All right. So now I was saying with this condition, all right, this is our condition. You find this, then you find the solution at the end. All right, so I'm just going to erase this so that we can have our solution properly here. So with that information, guys, I said where our f of x is above gx, we saw that it is in between here, this at C and the asymptote. Remember, it cannot pass the asymptote. So therefore, our x must be greater than minus 6, but less than. It is in between minus 6 and what? Minus 4. So it is greater than minus 6. Because there is an equal to, you can put that equal to on your answer. So x is greater than or equal to minus 6. But this x, guys, can never be equal to minus 4 because it is an asymptote. So it is less than minus 4. You cannot put the equal to there. You can't. You cannot do that. That's an asymptote. It is limited to that. So that's our first solution. The second solution is here from these values, from this intersection at E. Going this side, our F is above. Which values of X are we talking about? From -2, -1, 0, 1, 2, and so on. These values, they are greater than -2. But since there is an equal to on our question, you must have that one on our answer. -2 is not an asymptote, so we must put an equal to on that part. All right, that must be an equal to again here. So those were the two solutions, guys, that I was expecting you to have. It is limited. This one, remember, that's an asymptote. It cannot be equal to what? It cannot be equal to -4. So you're limited in within this. That was our 6.2. You see, guys? Yeah, it was an interesting question. But if you go through the videos, I have a playlist on those functions like effects of f of x and gx, the effect that can happen to the graph. If you check that, you see that I've mentioned a condition like this. So it's all about going through that introduction, understand more. All right. 6.3, a graph is represented by this. All right. Hx is equal to this, is drawn on the same set of axes of f and g, for which values of t will the graph h be a tangent to the graph of f, all right? What would be the condition that hx, all right? That's an interesting question again. That's an interesting question again that we are having there. They're saying for which values of x, all right? For which values of t, I mean, it's actually of t, for which values of t will h be a tangent, h be a tangent to the graph of what? To the graph of f. So if h is a tangent, let's say we have got that h and it is a tangent to f. F, guys, that's a hyperbola. So let's say here there's a tangent, here there's a tangent. The condition of a tangent is difficult for you to actually work with from our normal consideration. Look, this is, I mean, the condition of a hyperbola. Because we do understand that if h was a tangent, guys, that h that we are given to say hx is equal to x plus t, you're going to consider the gradient to say, all right, if it is a tangent, then its gradient is what? Is 1. So you're going to find the first derivative and say our first derivative is equal to m, where m is the gradient of what? That tangent, which is 1. But to differentiate now here with our syllabus, the way our syllabus teaches, we are limited on how to differentiate this. How to differentiate this? Because it's going to be -4 over x plus 4 to the exponent of -1 like this. You're dealing with a bracket. But if our syllabus was allowing us to differentiate this, of which you can using other method, there are so many ways. But I'm saying according to your syllabus, you are limited. So what can you do now? Besides the derivative, because you are limited because of that, what can you do? Again, a tangent, even though it is a condition that the first derivative of the function is equal to the gradient, it follows that a tangent on its own, where it meets a graph or whatever function, guys, at the point where these two meet, at that point, the two graphs will be equal. A tangent is just like, you see, the point of intersection. The difference is that when you talk about the point of intersection, you are used to when the line is crossing like this, then you say at the point of intersection, the two graphs are equal. What about at that point where the tangent meets with the curve? What happens? Also, it is the same thing. At that point, the two graphs will be equal. So at the point of tangents, all right, let us have that way. At the point of what? At the point of what? Of tangents, where the two graphs meet. The two graphs are equal. At the point of tangents, The two graphs are equal. The two graphs are equal. Just like what you consider when it is about the point of intersection. Only that for the tangents, there's a special property about the first derivative being equal to gradient that I explained on those derivatives. But yet, because of what you're dealing with to differentiate this, you are limited. So use the point of tangents where the two graphs are equal. Then solve for t, because you're simply saying this graph of minus 4 over x plus 1 minus 1 must be equal to that of x plus what? Of x plus t. Then you solve for t when the two graphs are what? When the two graphs are equal. All right, let us solve for t and see what is going to happen. If we are going to solve here, you're going to consider, all right, just like the previous one, we dealt with this type of a question before, if you still remember. All right, I can choose to simply expand or get rid of the fractions. X plus 1 here, I multiply by it, x plus 1, I multiply by x plus 1, I multiply by x plus 1. So it's going to be like this. All right, so this one is going to cancel. I have got minus 4 minus 1 times x. That's minus x. This is x plus 1 with x plus 4. Guys, let's see. This is x plus 4. Very sorry for that. This is plus 4 plus 4 plus 4 plus 4. Very sorry for that. So that will be minus 4, and yes, minus 1 times x minus x. Minus 1 times 4, that's minus 4, equal to, there I have got two brackets, x plus t and x plus 4. Let me just expand them, x and x squared and 4, that's going to be 4x. T times x, that's going to be tx. All right, and t times 4, that's going to be 4t. There I do not have like terms. All right, so I have got a quadratic equation where the highest power is what is actually a 2. And let us take collecting like terms here. We're going to have, all right, so it's going to be x squared minus x here is going to be a plus. So we're going to add x here, so it's going to be 5x. 5x plus tx, all right, plus what? Plus 4t. Minus 4 minus 4, that's minus 8. So if you take to the other side, it's going to be positive 8. It was a minus 8. So it's going to be positive 8, and that's equal to 0. All right. So this is what I want you to see properly here. This is a quadratic equation where you want to solve for t. So how do we solve for t? Because t is not the main term. Our main term is x squared, this and that. But remember, we are working with a condition where the two graphs are equal. So it follows that finding t, it is just like when you go back to nature of roots. T is hidden in within our terms. So go back to the nature of roots. For you to have equal roots, it means your delta must be equal to 0, because you're talking about equal roots when the two graphs are equal. That's equal roots. So to solve for t, you are simply going to use that discriminant concept. It was a hidden thing here. All right, how can we apply that? X is common for the first two, for these two terms. So I can factor out that x so that we can properly see our expression. Our expression is going to be plus. If I factor out x, I'm going to remain with 5 plus t. All right, so that's it. And here, this whole part is a constant. We do not have x. So let us just put it in a bracket like this. So we can see that t is hidden in within the x squared. But if we work out the delta, it releases that t that is hidden in within. So that was the most important idea. For us to have equal roots, for the two graphs to be equal, our delta must be equal to 0. So delta being b squared minus 4ac, we are simply going to calculate that 5 plus t squared plus, so where am I getting the plus now? Minus 4 times a. Our a is the coefficient of x squared, which is 1. Our c is the constant, which is 4t plus what? 8. So that's our delta. Expand these brackets, guys. 5 plus t squared means that we've got two brackets that we're going to expand, which we're going to give us 25 minus plus 10t actually plus t squared. All right. So that is what you're going to have from the expansion of the brackets. Then minus 4 times 1, that's a negative 4. Then negative 4 times 4, negative 16t. Negative 4 times 8, negative 32. So our delta, collecting the like terms, we're going to have t squared. All right. Then we work out the t, this is 10t minus 16t, this part of our t, 10 minus 16, that's gonna be negative what? Negative 6. So that's negative 6t. 25 minus 32 is going to give us a negative 7. All right, so that's our delta. And it is giving us a quadratic equation. Again, it's giving us a quadratic expression that we must solve when this delta is equal to what? When our delta is equal to 0, we must solve that. So therefore, t squared minus 16 minus 7 is equal to 0. Solve this. Are you going to need a quadratic formula for this, guys? No, let's just use our factorization. So that's t here. Factors of what? Negative 7, which will add up to negative 6. That's actually around negative 7 and 1. All right. To get a negative 6, this is the one. If you add, you're going to get a negative 6. So that's actually minus 7 plus 1. So t is equal to minus 7 to the other side was going to be positive 7. Or t is equal to 1 to the other side was going to give us a negative 1. All right. So these are the solutions that you're going to have, the values of t. Actually, the question, is it saying values? Let's go back to our question. All right. That was an interesting question. It is actually saying for which values of t. Yes, that is what you have. So meaning to say we are going to have more than one value. That's two possible values of t like that. So that was our question number 6. You see, guys, they just do repeat these things. So that is the concept, guys. You just need more revision, more revision. So that was actually 17 marks for this part, question number 6. All right, which is good. All right, which is actually good in terms of our revisions, guys. I cannot say bad about this. It is something good for your revisions. For revision purposes, yes, you need also to go through these typical exam questions. They are very, very important. You see that they are very, very important. All right. So I want us to check the other part, see what you have, but be very careful about this part here. All right. Then let us consider number 7. It was actually on our derivatives. And the first part, question 7.1, given f of x 3 over x, determine the first derivative from first principles. I have explained everything, guys, about your first principles. Go through the playlist of differential calculus. You'll see that we have explained everything that you need. All right, this is your first principles formula. You're given that from your formula sheet. So what you just need is applying the formula. As we can see that our first derivative with respect to x from our formula, that's going to be limit as h approaches to 0 of f of x plus h minus f of x. All right, everything over h. So what we need in our case is f of x plus h. We have this one, so we're going to need f of x plus h from our f of x. Our f of x plus h is going to be given as 3 over, in place of x, put x plus h there. So that's going to be x plus h. All right, let's take it into the formula, then try to simplify our first derivative, which is the limit as h approaches to 0, then we're going to have f of x plus h, that's 3 over x plus h. All right, x plus h minus our f of x, which is what? 3 over x. So that was it, everything over h. So what you're going to do is to simplify this numerator itself. It's just like a single term, so you have to combine it to be a single term, that bracket in the numerator, 3 over x plus h minus 3 over x. Guys, there are so many ways that you can do in terms of the simplification. You can have the LCD. You can easily swap these so that this will be x plus h. This will be x plus h over x plus h, and this will be x, you multiply by x over x, so that the denominators will be the same. 3 times x, that's 3x over x times this, that's x into x plus h, minus 3 times x plus h, like this. Everything over x into x plus what? X plus h. Since the denominators are the same, I'm just going to simply combine the numerators together. So that will be 3x, all right? Minus 3 times x, that's minus 3x, minus 3 times h, minus 3h. So let us simplify 3x and 3x. These are like terms, they cancel. You have got minus 3h over x into x plus h. All right, so that is what you're going to actually have at the end after simplifying the numerator, combining this. All right, then let us bring this into the formula. All right, sorry for that. I think it's my network. It's just, all right, no problem. So that's going to be limit as h approaches to 0 of this part that we obtained, minus 3h over what? X into x plus h. All right, then everything is over h. That's over h, like this. All right, so this is what I want you to understand here. I want you to understand, I have explained this on the introductions, that if you are given this condition of a fraction dividing another term, like what you have here, this is dividing h, divided by what? By h. So it's just like a over b, then it's over a, like that. This a and a can cancel. So this h and h can cancel. Therefore, our limit was going to be, as h approaches to 0, of what is remaining here, which is minus 3 over what? X into x plus h. And we can actually substitute the value of h, which is what? Which is 0, because we are saying our h is what? Being limited to 0. So that's in place of h, simply put as 0 there. All right. That is the condition. That is the condition that you're going to simply have. In place of h, you're going to have a 0. So that will be equal to minus 3 over what? X into x plus a 0, like this, which is minus 3 over x plus 0, that's x. So it was actually going to be x times x, which is x squared. So that's minus 3 over what? Over x squared. So that's the first derivative from what we have from our f of x. This is going to be the first derivative, minus 3 over what? Minus 3 over x squared. All right, easy like that, easy like that. Your first principles, they are going to ask this question with 5 marks. So actually, do expect anything from your syllabus, all right? Remember, from your annual teaching plan, I explained that they'll ask where f of x is equal to a over x, where f of x is equal to ax squared plus bx plus c for a quadratic, for a cubic, for a constant, then for a linear. Any one of these can be actually be asked in your revisions, all right? That is, you must know how to differentiate any one of those from first principles. So go through the introductions, the playlist for differential calculus. I have explained everything that you need to know in your syllabus. All right, 7.2, 7.21, we are asked to determine on 7.21 this derivative. All right, let us just try to apply our laws of exponents, the cube root of x squared. Remember, when x is raised to the exponent of m over n, it means the nth root of x to the exponent of m. So the power here is our numerator, the number in the root is our denominator, our power over this. So that's x to the exponent of 2 over 3. All right, minus x to the exponent of minus 3 over 2, everything over the square root of x. There's a 2, then here it's a 1, so that's 1 over what? 1 over 2, all right, to the exponent of 1 over 2. We are just trying to simplify first our dx before we can differentiate. Now that we have got this, we can separate these terms. Remember, that if I'm given a plus b over c, each term can be written as over c. All right, that's a over c plus b over c. So in our case, this was going to be dx of, if we separate these terms, you're going to divide by what? X to the exponent of 1 over 2. So that's 2 over 3 over x to the exponent of 1 over 2 minus x to the exponent of minus 3 over 2 over x to the exponent of 1 over 2. I haven't started to differentiate here. I'm just separating my terms. Now I can use the laws of exponents since I'm operating with the same base. I'm referring here the base of x, here also the base of x. Under a division, you are going to simply subtract your exponents. Xm over x to the exponent of n gives us x to the exponent of m minus n. So simply subtract the powers or the exponents. So that's 2 over 3 minus a half. And that was going to give us 1 over 6. Let's see. 2 over 3. Then we simply going to subtract a half. All right, 1 over 2. So this is going to give us 1 over 6. All right, so that's 1 over 6 minus, you do the same thing, subtract the exponents, minus 3 over 2 minus a half. That was going to give us a negative 2. All right, a negative 2. Let's see, negative 3 over 2, like this. Then you're going to subtract 1 over 2. So this is negative 2. All right, so that was going to give us a negative 2. Sorry, guys, I need to go back to the normal mode like this. So that was negative 3 over 2. All right, just actually changed everything. But guys, it was going to give us a negative 2 there. All right, so this is it. And with this, we can simply rewrite. Now we can differentiate. All right, remember what we needed was the format ax to the exponent of n, where we can simply drop the power. We know that the derivative there, you drop the power when you're given ax to the exponent of n. It is going to give us an x to the exponent of n minus 1. Drop the power, subtract 1. So here I'm going to drop the power, then subtract 1. So that was going to be 1 over 6 x to the exponent of 1 over 6 minus 1. That's negative 5 over 6 from your calculator. Do the same thing here. Drop the power, subtract 1. So minus 2 times minus 1, that's a positive 2. All right, then you subtract 1 on the power. So that's minus 2 minus 1, minus 3. You can actually leave your answer like this. You're not asked to leave your answer as positive exponents, this and that. So you can just leave your answer as it is at this stage, all right? So these are the steps actually that you're going to need. First, simplify in a way that you can differentiate. Then from there, you can differentiate. All right, 7.22, we are asked to find the derivative of y with respect to x, but we cannot see that y there. Like, what is the expression representing y is supposed to be equal to something in terms of x? but we can't see that from this. All right, so let us try to rewrite so that we can properly have y in terms of x. From x, y minus y is equal to x squared minus 1. Let us have y in terms of what? Y in terms of x. We're going to make y to be the subject in terms of x. All right? There is y and y, which is common from the left-hand side. So I can easily factor out y there. So I'll be left with x minus y divided by y. That's minus 1. And on the right-hand side, I have got a difference of two squares. One is same as what? 1 squared. So I'm going to have two brackets, a minus b into what? Into a plus b. So that's x and what? Minus 1. X minus 1, x and 1, x minus 1, x plus 1, like this. So I need y to be the subject. So that's a product. I have to get rid of what? X minus 1 divide by x minus 1. That is going to give us y in terms of x. As we can see, this was going to cancel and I've got a 1. 1 times x, that's x. 1 times 1, that's 1. So y is equal to this. All this that you're given simplifies to y is equal to x plus 1. So I can differentiate now y with respect to x. All right? Remember the derivative of y with respect to x for ax. If you are given ax, the derivative there is going to give us a constant, the coefficient of x. What is the coefficient of x? That's a 1. The derivative of a constant is what? A 0. If you differentiate a constant a with respect to x, you're going to obtain what? A 0. So 1 is a constant. Its derivative is going to be what? It's going to be a 0 there. So that is it. That is it. You are done. So that's the derivative of y with respect to x was going to be what? Was going to be a 1, just like that. All right. So you see, guys, just simple questions. You just have to be careful. Then this one, the gradient. All right, let's try to understand what you're given here. There's a tangent. Then we are told that the gradient of the tangent to the function f of x is, all right, this at a point 1, 5 is 12. All right. Remember the gradient of a tangent, guys. Whatever function that you're going to have at a certain point, it follows that the first derivative is equal to what? M, the tangent. That is the gradient of the tangent. So let me just write mt, the gradient of what? The tangent. So they are telling us that the gradient of the tangent is what? 12. So you're given the gradient of the tangent, which is what? Which is 12. At this point 1,5, that's at point 1,5, where I have the x value and the y value. So show that on 7.31, a is 2 and b is what? 3. How can we show that? For 5 marks. All right. From what I'm given, the point 1,5 lies on f of x. And also from the first derivative concept, it is equal to the gradient of mt at that point. So we can use two things here. All right, we're going to form an equation. One, from the tangent, concept or tangent concept, that if truly this line is a tangent, then the first derivative must be equal to what? Must be equal to the gradient of the tangent. So the gradient of the tangent is there is 12, but we do not have the first derivative. So let's find the first derivative from our f of x. So the first derivative, remember concept, you drop the power, you subtract 1. 3 times a, that is going to give us 3a, x to the exponent of what? 2. 3 minus 1, that's a 2. All right. A is a constant, same as B. They are constant. They are just like numbers. So do not worry about that. So here you do the same, drop the power. So it was going to be 2B. Then you subtract 1. So that's X. All right. 2 minus 1, that's a 1, which is going to be X. So this is your first derivative, which we are saying it must be equal to MT. At this point, where x is what? Where x is 1. So meaning to say, if I am going to equate to the numerical value, I must substitute the value of x when what? X is equal to 1. That's the point of tangents. At this point, x is what? 1. So thus 3a, our x is what? 1, plus 2b, our x is what? Our x is 1. It must give us mt. We are talking about this condition now. So that's the first derivative. When x is 1, it is equal to the numerical value of the gradient, and our numerical value is 12. So we have formed an equation. 1 squared, that's 1 times 3, that's going to be 3a plus 2b equal to 12. And I cannot solve for a and b, so I'm just going to have this as my equation 1. So I formed equation 1 from the tangent concept. All right. What about the point on its own? Because 1, 5 is a point which lies on what? Which also lies on f of f. All right. On f of x. This point 1, 5. It lies on what? On f of x. So if it lies on f of x, it means by substituting the y value into this and the x value, which is 1 here, in place of what? X. So it's going to be a times 1 cubed plus b times 1 squared. By substituting the value of x, I'm supposed to obtain y there as what? As 5. So because it lies on what? On f of x. So that's it. This is going to be 1 times a, that's a, plus 1 times b, that's b, which is equal to 5. So I have got two equations, but I can just simplify this, make a the subject of the formula, or I can make b the subject of the formula. It is in your hands. So let me just make a the subject. So a is equal to 5 minus b. So that's my equation 2, so that I can simply use what? Substitution method. All right. Since a is equal to 5 minus b, I'm going to simply substitute equation 2 into 1. All right. Equation 2 into equation what? Into equation 1. In place of a, here I'm going to substitute 5 minus what? 5 minus b. So that is the concept. So that's 3 times a, 5 minus what? 5 minus b, plus 2b is equal to 12. So we can solve for b. So let us solve for b. 3 by 5, that's 15. By negative b, that's negative 3b, plus what? Plus 2b, which is equal to 12. Collecting the like terms, that is going to be minus 3 plus 2, which is what? Minus 1b. So that's minus b plus 15 equal to 12. So I can take the 15 to the other side. It's going to be a negative there. That's 12 minus what? Minus 15, which is negative what? Which is negative 3. So that's the value of b. Divide by negative. Our b is going to be what? Our b is going to be 3. Exactly the value of b that we are given here, b is 3. So to find the value of a, I can use this equation 2. Since a is the subject of the formula, a is equal to 5 minus b, I can just substitute there. Since a is equal to 5 minus what? Minus b, therefore a is equal to 5 minus what? 3. So that's it. Our a is going to be equal to 2. So that's what you're being asked to show, that a is going to be 2 and b is going to be what? B is going to be 3. Just like that. So you see, guys, they are going to ask that issue of tangents. At the point of what? Of tangents, the first derivative is equal to what? To the gradient. So you can form an equation, then also form an equation from what? The point that lies on the graph. That point, it lies on the graph. So that is another advantage that we're given. Then 7.32, calculate the coordinates of the points on the curve where the tangent to the curve is parallel to the what? To the x-axis. What is the condition, guys, when the graph, when the tangent is parallel to the x-axis? When the tangent is parallel to the x-axis. This is our x-axis. A line, any line that is parallel to the x-axis has got a gradient of 0. It's a horizontal line. So its gradient is supposed to be equal to what? To 0. So that is the condition that they are simply asking you this time. So what you can simply do, since you have got the values of a and b, you can substitute them into what? You can substitute them into your original function, your f of x. Remember, we proved that this one is 2 and 3. So that's it. That's going to be 7.32. So our f of x, where a is what? 2, is going to be 2x cubed plus our b, remember, is 3. So that's 3x squared. So what I'm simply saying is that where the line is parallel to the x-axis, its gradient is 0. So it simply means our condition is where the first derivative is equal to 0. Remember, m represents what? The first derivative. When it is what? The condition of a tangent, it is what? The first derivative. Just like what we're given to say our tangent, its gradient was 12. This time it is 0. So you just equate to 0, knowing that you've got the value of a and the value of b. So let us find our first derivative, just like that, guys. That was the concept. So here we're just gonna do like previous, drop the power, subtract 1. That's gonna be 6x squared plus drop the power. That's gonna be 6x here if we subtract 1. So this is our first derivative, and we are simply saying it must be equal to what? It must be equal to 0, just like that. So if the first derivative is equal to 0, we're going to solve for what? We're going to solve for x. Then after that, substitute to find the value of y, because we need the coordinates. The question here is on determining what? The coordinates. So you must be very careful about that. All right. So that is the condition, guys. When this is equal to 0, 6x squared plus 6x is equal to 0. So for x, I can easily factor out 6x. That's going to be 6x and 6x. That's x plus 1, which is equal to 0. So that's the product of these two must give us a 0. So that's 6x is equal to 0, or x plus 1 is equal to 0. So divide by 6. That's x is equal to what? 0, or x is equal to -1. To the other side, this will be a negative. Then you must find the values of y, because what you need there is the coordinate. So from your f of x, when x is 0, what is the value of y there when x is what? When x is what? Is 0. So that's it. This was going to give us what? A 0. So that's a point that you're gonna have, which is 0, 0. All right. What about when x is what? -1, f of -1. In place of x, you just gonna put -1. So that's -1 cubed plus 3 into -1 squared. And this was going to give us a +1. So meaning to say we have got another point. That's when x is what? -1. The y value is going to be what? The y value is going to be a +1. So those are the points where the what? Where the gradient is what? Where the gradient is 0. The tangent will be parallel to the x-axis, like what we're given, that will be parallel to the what? X-axis. So you see, guys, direct. All right, that was it on this part, 5 marks. Then question number 8, given this information, all right, let us try to figure out what is it that they want us to do from this information. We are given 8.1. The following information is given, that is relating to a cubic graph, which is f. This is the information. Then from there, explain the meaning of the second derivative with respect is less than 0. For x is greater than 2. All right. Remember, when you're given the second derivative, it determines the graph, how concave, like concave up or down. So when you're given that it's less than 0 here, the second derivative is less than 0. It means it is what? Concave down. So the graph is actually concave down. For values of x that are greater than 2, it will be what? Facing down. That is the condition. Then draw a neat sketch of the graph of f, showing all relevant points. So we need a sketch. All right. From this information, what we can see here, all right. That's 8.2, 8.12. What you can see, we are given first f of 0 is what? 0. This is the x value. When x is equal to 0, y is equal to 0. So that's actually the origin. That's 0, 0 like this. So it can be x-intercept, it can be y-intercept at the same time, because that's what? The origin. All right, but if you're given here x is equal to 3, y is equal to what? 0. So this, when y is equal to 0, you talk about what? The x-intercept. So x is equal to 3, y is equal to 0. That's the x-intercept, this one. So we have got the x-intercept. But if we check the same value of x, where x is equal to 3. When x is equal to 3 here, we also have it on the first derivative here. Remember, the first derivative, for it to be equal to 0, it means you are dealing with the turning point. At the turning point, the first derivative with respect to x is equal to 0. So at the turning point, we have that x is equal to what? X is equal to 3. This is the value of x. The same x which we have as a what? As an x-intercept. So it is also a turning point, this one, where x is equal to 0. This means where x is equal to 3. Where x is equal to what? To 3. It is a turning point and also x-intercept. All right. Then this one where we have got 1 and 0, it means we will also have another turning point here. This one, where x is what? 1. First derivative, remember, to be equal to 0, it's a turning point. So we also have a turning point where x is what? Where x is 1. So where x is equal to 1, it's a turning point, that one. All right. So where x is equal to 1, it's a turning point. We do not know the y value, but we know that it's a turning point where x is 1. But here we know that it's an x-intercept. So at that point of x, 3, 0 is turning point. Then we have got the second derivative. The second derivative, it is showing us how concave up or down. But when it is equal to 0 like this, it means we're talking about what? The point of inflection. So this is the point of inflection when it is equal to 0. The second derivative of x to be equal to 0, that's at the point of inflection. So what is the value of x? The value of x is 2. So x is equal to 2. X is equal to 2 at the point of what? At the point of inflection. Then our graph, we are told that from that here, it is concave down. Remember, I explained this part here. It is what? Concave down. For x is what? So the graph is concave down for values of x that are greater than 2. Our graph is concave down. It is like this. For values that are greater than 2, it's going to be concave down. So let us have our sketch from this information that we just have. It simply means that if we are to take this properly, let's start with our intercepts. All right, let's say this is 0, 1, 2, 3, 4, and so on. We can see that, remember we said 0, 0 is the origin. That's the x-intercept, y-intercept at the same time, this one. All right. Then 3, 0 is what? The x-intercept. This one is an x-intercept. And also a turning point, this one. is the x-intercept. And remember, at that same point where x is 3, at that point, it is what? A turning point. So it is either, depending on the graph, it is either we're going to have something like this, because there's a turning point like this, or we're going to have something like this. Then it is what? A turning point like this. So between the two shapes, these two, which one are we going to take? Because we do not know about the value of A. Remember, if A is greater than 0, we can say, okay, the graph is like this. But here we do not know about the value of A of that cubic function. All right? This is just an information that you're told. We do not know the value of A. So we are going to test with this part where they say it is concave down for x is greater than 2. So consider a graph like this. Consider a graph like this. All right? Then consider another, because these are the only two sketches that you're going to have from these intercepts and turning point. This one is an x-intercept and a turning point, remember. Or it was going to be like this. It goes to the turning point, then at that point 3, it's a turning point like this. So if we say 2, the graph is concave down for values of x which are greater than 2. Concave down, that's our graph is going to be like this. For values of x which are greater than 2. At the point 2, it's a point of inflection. At a point where x is 2. So when you say about concave down, it's like this. Which shape maintains that at point 2? This is our 2. This one, like this. From 2 going up greater than 2, like going this side, the graph is concave up. It's facing up. From here, this is our 3, this is our 2 here. Our 2 maybe somewhere here, sorry for that. Okay, so let's say we have got our 2 here. From this point, we can see that our graph is what? Concave down. It is actually facing down like this. So this is the shape that we are going to have at the end. But remember that at 1, it is a turning point. So our shape was going to be like this. It passes through the x-intercept on the origin. Then at point 1, it is a turning point. So it is a turning point at point 1. Then at 2, a point. Just guys, you draw a proper shape, all right? You're supposed to draw a proper one. Then at 2 is a point of inflection, which goes to the what? To 3. And 3 is an x-intercept and point, a turning point. So the graph is going to turn there like this, concave, going down like that. So this was going to be the concave from this part here. It is concave down for x is greater than 2. From 2 here, it is concave down, facing down. So it cannot be like this, because if it is like this from 2, it will be concave up, it will be facing up. So that statement was very, very important. All right. So this is it, guys. All right. This is it. Let us indicate what is important. So that's the turning point. This is 2 going to the point of inflection. This one corresponds to the turning point. We do not know the corresponding value there of y. We just know that it is going to be a turning point wherever it is. That is our f. All right? Just like that. So you see, guys, you can sketch the graph from information given. And here they wanted you to do that. So you play around with that information, the knowledge. They are asking now, do you know these functions or these derivatives? Do you actually know what you're dealing with? All right. Anyways, that was the condition. Then another part on 8.13, determine the values of x for which the first derivative of x times f of x will be less than what? 0. All right. So this one also, guys, I discussed about these effects of f of x, this and that. So check a playlist. There's a playlist actually on the effects on f of x that can actually happen. So here we are given that was 8 point, all right. First one was 8.12. All right, this is 8.13 now. All right, 8.13. So I want you to see what is happening this time. They are saying we need values of x for which what? F of x times, I mean, its derivative times f of x is less than 0. So remember what I said when you are given the first derivative and another function. Here, advantage is that you are working with the same function. Whether it was the first derivative of this, maybe times gx, from the first derivative and that other function, your critical values are going to be, all right? So what you need there, what you refer to as the critical values in order for you to solve, you need the critical values. And the critical values will be, for f of x, you consider the x-intercepts. All right. So for the original function, this one, you consider what? X-intercepts. And our x-intercepts will be what? 0 and 3. So x is equal to 0 or x is equal to 3. These are critical values. Then from the first derivative concept to be applied, you must consider the turning point also as a critical value. At the turning point, x is equal to what? X is equal to 1, x is equal to 3. So I'm not going to repeat this one because we talked about these three. So x is equal to 1 is going to be part of the critical values. So critical values are the boundaries that you're going to consider. Your graph is subdivided into boundaries where x is equal to 0, like this. Where x is equal to what? Where x is equal to 0. It's a boundary, all right, that you must consider where x is equal to 0. Where x is equal to 1 is also a boundary to be considered. Where x is what? Where x is 1 at this turning point. So that's x is equal to 1. And where x is equal to 3, also this is a boundary to be considered when you are to find the exact solutions. So with these three boundaries, what will be our solutions? All right. Remember what I said, guys, from your introduction. When you are given the first derivative, because this is a product of two functions, the one for the first derivative, the one for the original function. So we need a condition that will give us less than 0, that it's either the first derivative is positive and f of x at that moment is negative, because this is negative, less than, so that's a negative. Or your first derivative is negative and your f of x is positive. So how do you tell that the first derivative is negative? That's the concept. Because your f of x is easy, guys. You can tell from what? From the x-axis, it is our boundary. From the x-axis, anything that is above, anything that you consider, like this case, anything that is above the x-axis is positive. Below the x-axis is negative. For what? F of x. That is how you simply consider that one for f of x. Anything below the x-axis is what? Is negative. Above the x-axis is positive. But what about the first derivative? The first derivative, you work with how the graph is considered. When the graph is decreasing, when there is a decrease, the first derivative at that moment will be a negative. When there is an increase, the first derivative is going to be what? Is going to be considered as a positive. That's how you work with this. So let us consider that, all right? Remember your critical values. From 0, we are going to consider going to the left. -1, -2, going to the left. What is happening? Our f here, this is our f, is above the x-axis. Take note. This is our x-axis, remember. So our f is what? Above the x-axis, meaning to say our f is positive. Remember the condition, f prime times f of x. So from these values of x that are less than 0, our f is above the x-axis. It is what? A positive. What about the first derivative? All right, let's look what is happening on the graph. The graph of f is going down. For these values of x, y is decreasing. Y is going down. Look, y is going down. So the graph here is a decrease. Where there's a decrease, the first derivative is what? Negative. So meaning to say, if you multiply these two, you're going to get a negative value. So this region satisfies what we want, where x is what? Are values that are less than 0. 0 minus 1 minus. You see, the graph is decreasing. So the first derivative is a negative. But this graph is above the x-axis. For that moment, the y values are positive. They are above what? The x-axis. So that's why I'm saying my f of x is what? Is positive. So this region was going to satisfy what we want for values of x that are what? Less than 0. So the first one was going to be x is less than 0. All right, let us move on to another one. Remember, you work with critical values. You started with what? A 0, going to the left. Since there's a critical value there at 1, so you must consider in between 0 and 1, because those are critical values. In between 0 and 1, what is happening? All right? In between 0 and 1, our graph is below the x-axis. Our f of x is found below the what? Below the x-axis. So it is a negative. What about the first derivative? What is happening with the graph? Guys, this is a decrease. The graph is still decreasing. It is decreasing up to the turning point. So when the graph is decreasing, like what is happening here, the first derivative is what? A negative for a decrease. The graph is still decreasing. So the first derivative is a negative. So when I multiply a negative to a negative, I'm going to get a positive. So this region is totally out because I need negative values, not positive. So from 0 to 1, there is no solution from 0 to 1. Yeah, there's no solution. There's no solution. Up to the turning point, the graph changes. Now the graph is going up. The graph is what? Increasing now. In terms of the y values, they are increasing. So we consider that region between what? Between 1 and 3. Between 1 and 3. Those are the critical values. 1 and 3. In between. What is happening in between? Let us check. I have already explained what is happening about the graph. The graph is now going up. The graph is what? Increasing from the turning point. The graph is increasing. So when the graph is increasing, it means the first derivative is positive when the graph is increasing. What about f of x? Our f of x is the y values of the original function. It is still below the x-axis. As long it is below the x-axis, the y values, they are negative. Yes, the graph is increasing, it is going up, but it's going up being what? Being below the x-axis. So that is not going to affect that part of positive. It's going to remain as a negative because it's below the x-axis. Yes, the first derivative is positive because the graph is what? The graph is increasing. So positive times negative gives us what? A negative. Exactly what we want. So this region is required from 1 to 3. In between 1 and 3, your critical values, you're going to need that. So x is greater than 1, but less than what? Less than 3. In between. All right, let us move on to the last region. The last region is for the values of x from 3 going this side, greater than 3. For these values greater than 3, the graph, we are at the turning point. The graph starts now to go down. It is decreasing. The graph is decreasing. Look what is happening. It's going down. So the first derivative is negative. What about f of x? Still, it is below the x-axis. So your f is negative. Negative times negative gives us a positive. We do not want that. So this region is totally out. So according to our critical values, where we have got the first derivative and the f of x, 0, 3, and 1, these were going to be our solutions, where the first derivative times f of x is less than 0 gives us a negative. You simply interpret that from the graph. All right, so guys, please do watch the introduction, the basics. All right, I've talked about this, so you can actually add as much information as you can from that. All right, then it is further given on 8.2, it is further given that the graph of f passes through the point W. This f that we are talking about, it passes through the point W. Determine the equation of the graph and leave your answer in the form. This is the format that you're given, where P, Q, R are what? Are constants. So W is a point where f of x passes through. All right. So let's see how can we obtain the equation. So guys, this one is direct. It's actually direct and straightforward because we've got a point already. There's a point. So we can take advantage of that point that you are given. Remember, when you are given this condition where a point is a turning point and also x-intercept, when this occurs that a point is a turning point and x-intercept, it follows that the function of x will be given by a into x minus x1, the first x-intercept, x minus x1 into x minus x2 squared. That's where there is a turning point and also it is the x-intercept. You square that part, you take that solution, then square it. So it means our f of x was going to be equal to a into x minus x1. The first x-intercept, remember, it's on the origin, where x is what? Where x is 0. Times x minus the other value of x, that's the x-intercept 3, which is also our turning point. So it's x minus 3 squared. Since you are asked to write this equation, where it passes through the point W, where we are given x and y there, simply substitute those, then find the value of what? The value of a. Because this simply means our f of x is equal to a times x minus 0, that's x, into what? Into x minus 3 squared. So I can easily or simply substitute that point W because W lies on what? On f of x or on f. So if it lies on f, where our y is what? Negative 40. At that moment, x is what? X is 5. Calculate the value of a. All right, x is what? 5. So that's 5 minus 3 squared. All right, so minus 40 is equal to a times, I'm just going to simplify this, 5 open bracket, 5 minus 3 squared. This is going to give us a 20. So that's a times 20 divided by 20. That's a product here. So divide by 20 by 20. So a is equal to what? Negative 2. So if a is equal to negative 2, I can substitute it back, then simplify, because what I need is to have my equation. Remember, in this format, f of x, it must be expanded format. You must expand that. So it simply means our f of x is equal to a here, that's minus 2x, all right, into x minus 3 squared. So expand x minus 3. This is x minus 3 squared. You can have two brackets that you expand there, but that was going to give us x squared minus 6x plus what? Plus 9. Then expand by minus 2x. So that's minus 2x cubed. Minus 2x and minus, that's plus 12x squared. Minus 2x, and this is going to give us negative 18x. Exactly the format that we are given there. So that is how you can easily or just simply play around with that question. You're asked to find your f of x in that format. So this is it. All right. You see the cubic function. You can determine its equation. It just varies with what you're given. In this case, we took advantage of what? The x-intercepts. We are given x-intercepts, and one of these x-intercepts is a turning point. So we have to square that. That is the condition. All right, let us move on to another question, which is question number 9. An industrial chemical is stored in a rectangular containers, with a square base of X centimeters. So the base here is a square, all right, of X centimeters. So that's the base, and this is the height. So the base, it was supposed to be rectangular, where we've got length and breadth, or length and width, length and breadth. So let's just say this is our length, and this is our breadth, and this is our height, which is given as what? As h. So we are given that the height is h centimeters. Then the volume of each container is 2,160,000 cubic centimeters, right? That's a lot. So this is the volume. Then from there, we are asked 9.1 to determine the height of the container in terms of x. All right, so the height of the container in terms of x, guys, we can simply work with the volume. Remember, we have got the volume. This one we are given. So 9.1, we need h in terms of what? H in terms of x. So from what? From the volume. We do understand the volume is what? Area times what? Area times height. Base area times height. So it was supposed to be length times breadth. But in our case, the length and the breadth are equal. It's a square base. So we're just going to multiply x times the perpendicular height. So that's our V. Which is what? X times x, that's x squared h. So that is your volume expression, all right? Where the volume numerically we have its value, 2,160,000. Substitute that is equal to x squared times h. Remember, what we need is h in terms of x. So we can make h the subject of the formula if we simply divide by what? If we simply divide by x squared. All right, so by dividing here by x squared, all right, by x squared, we have got h as the subject of the formula. So therefore, h was going to be this, 2,160,000 over what? Over x squared. So that's it in what? In centimeters. All right, so that was the idea. And we are given now here that on 9.2, for safety reasons, during the transportation of the containers, a triple layer of material is needed at the base of the container. Then ignore the thickness of the material, all right? Show that the total surface area of the material used for the container is given by this formula, the total surface area. All right. So guys, whenever you are working with this type of a question, you apply it according to the information that you're given. It's practically you have to apply it. So look what is happening. They said the square base here was what? Was tripled. So it was actually a triple layer on the what? On the base. It's only the base. The one that is the one that has got what? A triple layer. And what you need here is the total surface area. All right. Remember, guys, what happens? Remember how you were dealing with the total surface area before. All right. So that's 9.2. You were saying that the total surface area, if you are given a cuboid, which is length, base, and height, the total surface area you're taking as 2 into length times breadth, all right, plus length times height, plus breadth times what? Breadth times height. This is how you're going to have your formula, but you are limited because this part here, which has got the length and the breadth, this part of the length and breadth cannot be multiplied by 2 because it is the base which was being tripled. So it means the top was not tripled. The top remained as it is. So from here, we are going to separate our formula. This here is going to be separated. Our area instead is going to be length times breadth. Let's say this is our length, this is our breadth of the top. Then here the base, it is triple layer. So the base is going to be 3 times length times base. All right, it was supposed to be like this, 3 into length times breadth, which is our length is x, our breadth, remember they're the same. So it's just x times x, which is what? 3x squared, x times x. All right, that is the base, this one. It was triple. Then the top is separated. So you're going to add the length and the breadth of the top. Length and the breadth, which is x times what? Which is x times x. This is the top. All right. Then these are the sides now. The side, these ones are not affected. They're going to be multiplied by 2 as we are used to. So this 2 was going to affect here, guys. This one is not affected at all because it is not part of the trip. Remember, they said ignore the thickness. So the thickness is not there. So it was going to be 2 into length times our height. Remember, our length is what? Our length is x. Our height is h. All right. Plus 2 is not here, is not affecting, like there's no effect. It's just going to remain as it is. So it's 2 times what? The breadth. Remember, our breadth is what? Is x times the height. So this is what you're going to have at the end. So our area was going to be simplified. Be very careful about this. So this is the triple of the square base. You multiply by 3. So x times 3, that's 3x squared, plus x times x of the top, that's x squared. Those two, you simply add. This is 2xh. This is also 2xh. So 2xh plus 2xh is going to give us what? 4xh. So that's 4xh. And here I've got like terms, so I can add 3 plus 1, that's 4x squared plus 4xh, just like that. All right. So remember, it is supposed to be in terms of x. If you see the way that our answer is given, it is in terms of x. So what happened? They just substituted the h. Remember, h is equal to this. So in place of h, substitute that. So meaning to say our area was going to be 4x squared plus 4x times our h 2,100,000. All right, let me just change this one. 160,000 over what? Over x squared. Remember, that was the height. So you substitute that height, then simplify further. So that's 4x squared. This here is going to be x into x, that's 1, into x squared, that's x. So multiply 4 times 2,160,000. If you multiply the numerator to the numerator, was going to give us 8 million, all right? So this was going to be 8,640,000. All right, everything over 1 times x, which is x. Exactly the given expression for our area in terms of x. So here, that is going to be our area in terms of x. Here it was in terms of h and x, but the final answer is our area in terms of what? In terms of x. All right, just like that. So you see, guys, it's just playing around with your questions, just playing around with the information. Mathematics is just about playing around, guys, you see? Just like that. So let us consider another part, which is 9.3. On 9.3, we are given a condition to determine the dimensions now. All right, we need the dimensions of the container. All right, but these dimensions will ensure that the minimum amount of material is used when making containers. So when making containers, the material is the one that is this one for the total surface area of the material. So already we are talking about what? The minimum area. For us to have the minimum amount of material, we must work with what? The minimum area from there. So what will be the dimensions if we are talking about what? The minimum area. we are back to maximum and minimum values optimization, guys. So for minimum values, we do understand that the first derivative must be equal to 0 for us to have what? A minimum value. The first derivative of what? Area. What is giving us the material, building that material is the area. All right. If it was the capacity, work with the volume, but here's what? Area. So that's the minimum value. The first derivative of area with respect to x must be equal to what? Must be equal to 0. So I must differentiate the area. All right. So let us find this. Remember, our ax is equal to 4x squared plus this. You take x up, it's going to be a negative. So that's 864,000 x to the exponent of -1. Then the first derivative of our area here with respect to x is going to be, remember the concept, drop power, subtract 1. So that's it. 2 times 4, that's going to be 8x. If you subtract 1, that's going to be 8x. All right. Drop the power, then subtract 1. So it's going to be -864,000 x to the exponent of what? -1 minus 1, that's a -2. You drop the power, you multiply, that's going to be a negative. So this is our ax. And from here, we are saying this area must be equal to 0. So simply take this, equate to what? To 0. 8x minus 864, this here must be equal to 0. Then solve for x, all right? I can simply take this to the other side. So it's going to be 8x is equal to 864,000 over x squared to the exponent of -2, guys. That -2, you can just write it in the denominator as what? Over x squared. So this is over 1, so that you can easily cross multiply. Here it's going to be easier, all right? If you do cross multiply, all right, it's going to be easier to get rid of the fraction. 8x times x squared, that's 8x cubed, all right? Sorry for that. 8x cubed, 1 times this, that's going to be 864,000 like this. All right. Since I want x, I'm going to simply divide by 8 here. So that's obtaining x cubed. So that was going to give us 1,080,000 representing x cubed. All right. What about x? Introduce the cube root. Since we've got a cube, so you're going to introduce the cube root both sides of our equation. So the cube root of this, the cube root of 1,080,000 is going to be this. And to 2 decimal places, let us fix this to 2 decimal places. That's 102, comma 6, all right, 102,60, which is just 2 centimeters. That's the part of the dimensions. Remember, x is the base, right? We need the dimensions here that will make a minimum, the dimensions of what? Of the container. And the dimensions of the container are given by x and h. So we have got x here from this dimension. We've got our x, which is what? 102,6 centimeters. What about h? What we need now is to find h. All right, remember, we had this h in terms of x. I don't know if I all right, if you check here, this was our h. It's only that I erased, but this one, 2,160 over x squared. That was our h, remember. So we can find h from there. Since we've got the value of x, and we do understand that h was given as 2,160,000 over x squared. So when x is this value, what about h? So simply substitute the value of x, 102,6 squared. This is going to give us the height. So our h from there was going to give us 205,19 centimeters to 2 decimal places. So these will be the dimensions. That's the x. Remember, that is the square base. So that's the length and the breadth and our height. So that is it for this part, right? For this area to be minimum, thus we are going to have minimum material used for us to have what? The minimum amount of material used. So you simply apply the first derivative. Even if it was maximum value, the first derivative must be equal to 0. You simply differentiate, all right? Equate that one to 0, form equations from there, then solve whatever that you're being asked. So that is it. That is how it can be like. That is how these questions can actually be like. That is it, guys. A total of 150 marks. So let there be light, guys, in our revisions. As we are revising, let us be led by what? By the light in our revisions till we meet again.